From data, designers construct visualization structures without relying on a data schema. Data tables are shaped later from the structure of graphics. We demonstrate the power of the approach through a gallery of visualization examples.
The classifier trained on the historical data may fail to classify the incoming data when the data distribution is changing. This phenomenon is called concept drift. To handle the concept drift, we developed the Drift VIS, a visual analytic system to help the expert understand when, where, and why the drift happens, and update the model to improve performance.
Attention mechanisms have greatly improved the performance of many language models. Yet with great power comes increased complexity. In this work, we present attention flows, a visualization that let users interpret the language model's decisions and gain insights into the underlying self-attention mechanism. We also support model comparison that helps to fill the gaps between models in different training stages.
Do these three essays construct their argumentation similarly? Where in this table of argumentation data from the previously seen texts can I find certain argumentation patterns? Do these three argument maps depict the same argument? We have developed a visual analysis system for argumentation in essays that can answer these questions at a glance. You want to know how it works? Come to my talk.
We propose a new semi-automatic method that uses topological features to guide users in tracing neurons and integrate this method within a virtual reality framework. We use the Morse-Mel complex to find a set of candidate neuron arcs. The candidate arcs are integrated into a VR neuron tracing system and exposed through our Morse-Mel complex guided semi-automatic tracing tool. The topological ridge graph underlying our MSC guided tool is robust against gaps in the signal.
VIS is a visual support system for the development of visualization algorithms. It has live compilation, automatic version control, predefined interactions, and tools for visual parameter analysis. By displaying the complete history of the algorithm, users get insights into the correlation between source code changes and visual differences. We have seen many visualizations for tree data structures, but when showing changes in trees over time, some focus on displaying hierarchy, while others highlight their changes. With split streams, we combine two approaches and their individual benefits. We evaluated our method in a user study and consider it a general-purpose method for the visualization of dynamic hierarchies. Our JavaScript library is openly available.
As data is changing, our understanding of data should be updated correspondingly. Based on machine learning approaches, we formulate a drift level index to monitor the evolution of multi-source data, which allows users to capture and reason significant changes from time series data. The proposed visual analytics system is called Concept Explorer. More details can be found in our talk.
We asked participants to recreate bar graphs. When the bar was alone, we saw a different pattern of error than when the bar was presented with context in a stacked bar graph. We find that absolute error increased for higher bars when they were presented alone. We also found that there was a bias in the responses such that they were repulsed from an implicit 50% mark. We found a magic number, 10%, to predict error. Participants are usually within 10% of the height of the bar.
In our paper, we address the problem of navigating complex multiscale and dense environments, such as these molecular models. We present a technique for browsing a model by clicking on textual labels, which we call hyperlabels. This allows the user to intuitively navigate the hierarchical organization of the model. For more details, read our paper or watch the talk.
Progressive visual analytics provides intermediate results in the middle of computation to address a long computational delay. However, such intermediate results are uncertain, so findings from these results can turn out to be incorrect for the entire data. In progressive visual analytics with safeguards, we suggest to risk the uncertainty, but we allow humans to leave safeguards every time they risk the uncertainty.
As commonly known, dimensionality reduction techniques and their interpretations are complex, biased, and uncertain. In drug design, this highly complicates the search for similar and new chemical compounds. To overcome this issue, Canva brings comparison of different molecular descriptors and properties into one tool, featuring planar, 3D, and table views for evaluating the trustworthiness of high-dimensional data projection.
Syringe graphs are variants of stack graphs with curve-based line, and the main factor affecting its readability is the sign allurance through a perceptual inconsistency of the orthogonal and vertical direction. Aiming at reducing its impacts, we revisited the baseline formulation and proposed the concept of composition to help the syringe graph layout optimization. The result shows that our algorithms perform better than the others.
Hands-on cybersecurity training represents a domain where visual analytics can significantly improve the impact of teaching process. We describe this new application domain and introduce a conceptual model that can serve as a framework for the development of analytical visualizations. Unified training lifecycle will be discussed from the perspective of different user roles.
Linking and brushing is very useful for interactive visual data exploration. Data-driven brushing tools are getting popular recently and achieve good results, for example the Mahanoda-based brush and the CN-based brush. However, these brushing tools are optimized by the data from a large number of users, which are not suitable for everyone. In this paper, we introduce an adaptive brush model which takes the user in a loop to improve the brushing accuracy.
Asteroids have always been and will always be a threat to life on Earth. Most likely, an asteroid will hit deep water, but what properties will actually lead to a threat like a tsunami? Ensemble simulations are a common tool to understand the effect of different parameters like the size of the asteroid. We propose an interactive visual approach to help analyzing deepwater asteroid impact simulation ensembles.
Program developers spend significant time on optimizing and tuning applications. But working with binary code to understand what compiler optimizations were applied can be challenging. We present our visual analytics system, CCNAV, designed to identify and assess compiler optimizations in binary code. Check out our paper to learn more.
When developing a deep learning model, people typically struggle to optimize hyperparameters that are affecting the model performance. To relieve the pain of this manual trial process, AutoML has been developed as a solution. However, to maximize the potential of the AutoML, people should identify a good AutoML setting for their task. Hypertendril helps to maximize the potential by visualizing AutoML algorithm behavior and guiding effective hyperparameters.
In this talk, we introduce CallFlow, an interactive visual analysis tool that provides a high-level overview of performance profiles from large-scale scientific applications. CallFlow visualizes the flow of resource of a program execution as a Sankey diagram to detect performance bottlenecks in parallel codes. CallFlow simplifies these calling context trees based on semantic information by constructing supergraphs.
Several recent studies advocated the use of non-parametric density models for the improved characterization of data uncertainty. The non-parametric models, however, present the challenges such as increased memory and computational requirements. In this work, we propose an efficient non-parametric framework for volume rendering in the context of uncertain data and show their effectiveness in classifications via comparisons with the other statistical models.
How many clusters can you see in these images? With different visual encodings in scatter plots, our perception of cluster count changes. We developed models that consider how visual density influences cluster perception. Further, we demonstrate using a threshold plot to optimize the saliency of clusters.
In our current work, we visually compare two cohorts of segmented and classified tissue images, originated from single-cell omics data. To that end, we developed data-driven and interactive workflow implemented in a multi-linked view system. Finally, we show the effectiveness of our workflow through specific case studies.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau, answer questions at the speed of thought.
Text alignment is a fundamental technique in many text-related domains. In this survey, we cover 3 text alignment scenarios: collation task, text reuse detection, and translation alignment. On the basis of those scenarios, we reviewed the existing text alignment visualization approaches and discussed their advantages and drawbacks. We finally derived design implications and shed light on related future challenges.
We present the first generic design space and library for visual piling. Inspired by physically piling paper documents, visual piling describes an interface for spatial organization of visual artifacts into piles of partially overlapping items. Piling affords interactive grouping, arrangement, previewing, browsing, and aggregation to reduce the complexity and support comparison of large collections of small multiples.
How do you visualize the nanoscale, 1/1000th of a meter, for the public? As part of a Science Center exhibition, we developed an immersive environment that explains nanoconcepts by allowing users to explore nanoproperties. We reflect on how exploration, the confluence of explanatory and exploratory visualization, can be applied to visualization in public spaces.
We propose an interactive ensemble analysis framework that provides flexible interactive exploration of the ensemble data. Time series characteristics of data can be obtained by fast browsing time steps. The region stability heat map view shows the stability of the selected region and provides region adjustment by directly clicking.
Visualizing class separations is used in applications such as classification and clustering. However, many dimension reduction techniques are limited due to the issues of separability and interpretability. We propose a visual analytics framework to support the exploration of nonlinear complex separation structures with the power of locally linear separations.
Hello, and thank you for joining us for FailFest, a workshop celebrating the scientific value of failure. This workshop was organized by Jordan Crouser of Smith College, Paul Rosen of the University of South Florida, Lonni Besançon of Norrköping, and myself, Jane Adams of the University of Vermont. The idea for this workshop was launched last year at VIS during a meetup about building an inclusive VIS community. Reflecting on my past VIS experiences, in particular the VIS Up-Down panel in 2010, I spoke about how important it is for students and early career researchers to hear the struggles of mentors and heroes in the visualization research community. These stories humanize an academic process that can be increasingly challenging as we see the continued growth in volume of spectacular research under consideration for conference publication. The intention of this workshop is to normalize admission of failure and community support for the unpredictable, sometimes disheartening or devastating process of scientific research, and to encourage visualization practitioners to contextualize failure as vital to the development of novel scientific achievement. Critically, this workshop focuses not on the failures of others, but on personal failure, in the hopes that authors and speakers will be more intimately familiar with not only the technical and factual details of the particular failure, but also with a first-person perspective of the emotional distress or personal growth that these experiences can engender. Especially for people who are new to the field of visualization, new to academia as first-generation college students, or for those who don't speak English as a first language, paper rejections, failed experiments, and burnout can really sting. As a community, we should ensure that these setbacks don't become an obstacle to entry into the field or precipitate dropout among those who are undersupported or underrepresented. There is a precedent among other fields to encourage publication of unsuccessful research. Notable publishers Elsevier and Nature have promoted editorials in recent years encouraging academic discourse on failed results. As academics, we are woefully familiar with the reproducibility crisis in publication. The replicability of medical and social science research is particularly elusive. If VIS is any indication, information visualization applications within these disciplines is widespread, and the reproducibility issues of these disciplines should also be of concern to our community. In 2002, the Journal of Negative Results in Biomedicine was launched as a peer-reviewed journal for publication of null outcomes in biomedical research. 15 years later, in 2017, the journal was sunsetted, saying that its purpose had been fulfilled as negative results became accepted as a valid scientific contribution to the biomedical research community. Similarly, the All Results Journal series still operates, publishing both successful and failed results across disciplines of nanotechnology, physics, chemistry, and biology. Taking cue from these examples in other fields, we're curious to know what a failure-tolerant visualization research community would look like, both in terms of publication and in the sharing of personal anecdotes from successful career academics at conferences such as this. It's easy to see visualization failures in the wild. As mentioned this morning, VIS in the time of COVID has especially brought to light some egregious choices in graphical representation that can have devastating effects on public understanding of serious world events. Sometimes these distortions are intentional misinformation, but they can also simply be the hazardous accidents of scrambling to visualize data in a timely manner, or mistakes driven by novice visualizers keen to make sense of the world and communicate their findings, but which lack of familiarity with visualization literature. We all gleefully engage in admonishments of rainbow color palettes, disappearing baselines, 3D bar charts, and pie charts which don't sum to 100%. But what can we do as a community to stop those visualizations before they happen? While the potential to be lampooned on Twitter might be a deterrent for some, how can we acknowledge our own shortcomings in research? How might the discussion sections of our papers focus more on the caveats that we ourselves as authors identify, rather than reiterating how novel and flawless and vitally publishable our work might be? How often do Viz academics issue retractions of previous papers, revise prior statements in the context of new literature and computational advances, and normalize the behavior of changing one's mind on a subject? Research can be an isolating experience, especially these days as we work from home, face travel restrictions, and confront an academic employment landscape that is increasingly competitive. In the context of mental health, how do we prevent burnout among our community, preserve healthy work-life balance among academics, and help our fellow Viz friends see rejection not as an outright failure, but as the beautiful result of thoughtful peer review and an opportunity for growth? The truth is, as organizers, we don't know what some of these answers might look like, but we're so glad that you are here to help us imagine some possibilities. We encourage you to share your questions and thoughts in the FailFest Discord channel, through comments on the YouTube live stream, or with us on Twitter at fail_fest. Q&A will follow most presentations this afternoon. We're grateful to our speakers, Leilani Battle of the University of Maryland, who will be walking through a template on how to respond to reviewer feedback on Viz papers, and Nadia Bremer, who will be sharing her ups and downs of visualization in practice. We're so thankful to our paper authors who will be sharing their own experiences with visualization research failure and insight into how DataViz PhD students cope with rejection. We're delighted also to share our conversations with our panelists, Alberto Cairo, who speaks to the value of failure in visual journalism, Kristen Cook, who shares her experiences with the unexpected in the context of a national lab, Stephanie Evergreen, whose communication consulting work offers insight into Viz failure in industry, and Alark Joshi, who has studied the value of peer and mentor relationships in visualization computer science research. Thank you all so much for joining us. Also, we would like to extend a special thank you to the Viz Core Committee, IEEE Explore, the Workshops Committee, our student volunteer for this session, Maria, and especially to the tech team. Transitioning to a virtual conference format, coordinating with literal hundreds of humans across many time zones is no small feat. Throughout the week, keep these unsung heroes in mind. We couldn't have done it without them. So without further ado, we begin the first ever FailFest workshop. Hi everyone, my name is Jane Adams. I'm a data visualization artist at the University of Vermont Complex Systems Center and a member of the MassMutual Center of Excellence in Complex Systems and Data Science. I'm one of the organizers of this workshop. It's our inaugural year as FailFest, and I'm super excited to be on this team and to be presenting these really incredible talks from so many brilliant and thoughtful people in our community. Failure is a really important topic for me, kind of coming into the field of data visualization from the world of fine art and trying to become acquainted with all of the grammar and all of the structure around academic research, and also the technical tools that may not be so familiar to people kind of coming from an interdisciplinary world. And so I'm really glad that you're all here. I decided to film this video here at my house in Vermont. It's one of the the last really beautiful days that I think we'll have for a while, so I wanted to share the foliage with you. I just wanted to talk a little bit about kind of my background and how I think about failure and its importance in the scientific process, and also where I'm coming at it from as a designer and thinking about the design thinking process as well. I started thinking about failure and iteration from the context of design thinking. This is a really wonderful graphic from the Stanford D School that basically walks through the steps of the design thinking process, from empathizing to defining a problem, ideating through that problem, prototyping, testing your prototypes, making assessments, and then as you'll see down on the corner here, this is not necessarily linear, apply as needed. And so this is kind of a cyclical process as we keep making adjustments to our designs and incorporating user feedback. And so it started to occur to me as I kind of entered the world of academia, and I'm working a lot with data scientists and analysts, that the design thinking process is really not that different from the scientific method, where we're asking questions, doing background research, constructing a hypothesis, testing with an experiment. Experiments and prototypes are very similar when we really get down to their fundamental function. Analyzing results and drawing conclusions, and then reporting results and developing new experiments based on that feedback. So when we think about the challenges that we face in visualization research, visual analytics, and also VIS in practice, a big question that comes up is, how do I start something that I don't know how to do? In design thinking approach, we start with making very low fidelity prototypes. The idea here is that you fail early and you fail often. If you come up with a design as your paper prototype and things don't quite work out the way that you wanted to, the only thing you have to throw in the trash is all your pieces of paper, which is a lot more kind of manageable than having to scrap an entire GitHub repository or trying to scrap 6 months of work. If we can build those low fidelity prototypes and get to that user feedback sooner, then it's kind of better for everyone, and it makes our loss a lot more manageable. Also, I think that iteration happens simultaneously across multiple segments. So when we're thinking about this prototyping process, not only are we often prototyping our visualizations, but we are also making iterative changes to our paper, making changes to our code, and those are all happening asynchronously. And so keeping all of those things aligned really requires a lot of reflection and a lot of careful computation. And sometimes in science and in life we fail, even if we've been working iteratively and we've been making a lot of small failures along the way in the hopes that things, when they get to the point of being a published paper or being a dashboard that's deployed in an enterprise situation, sometimes those things still don't work out. Sometimes client needs change. Sometimes the journal isn't looking for the topic that you've chosen. And so I think it's really important that we, as a community, share these stories of failure and really normalize that and kind of get in the habit of talking about how failure is really an integral part of the scientific method, of design thinking, and how can we make light of that failure? How can we minimize that failure? How can others learn from our own failure? So, if enough people make the disappearing baseline mistake on a bar chart, and we talk about those mistakes enough, then maybe we'll see less of them in the wild. So my hope is that this FailFest can be an opportunity to kind of share those stories, learn from each other's experiences, and really acknowledge that failure itself can be a contribution to the scientific community as well. So whether we call it design thinking or the scientific method, it's really important to fail early, fail often, keep iterating, and share your stories of failure. In this being our inaugural workshop, we're hoping to get some feedback from all of you attending on how we can change the format or integrate more kind of a hands-on workshop feel to it, so that for those of you who had rejected papers this year, or who have visualization applications that aren't quite working, how can we as a community support you and support one another in figuring out what went wrong and pivoting and adjusting course accordingly? Thanks so much for attending.
Hi everyone, my name is Lonni.
Sure, I can.
Besançon, and I'm a postdoc in human-computer interaction, previously working at Linköping University in Sweden, and soon to be working at Monash University in Australia. I'm very excited to be a part of this amazing team of organizers to talk about failure in research, which I believe to be one of the things that really deserve our attention as a community. Of course, I believe that failures deserve to be a topic of discussions for very specific and personal reasons. I, in fact, started my PhD with quite a lot of failures, failures that I learned from to become eventually what I hope is a better researcher. Out of all these experiences, I would love to talk about the first one I had, which was really intense and shaped me into the scientist I am today, I would say. It's about my first paper submission and rejection, and I guess it could be a nice way to introduce you and tease you a little bit about one of the fantastic papers that we'll be presenting during our workshop today. So I started my PhD at the end of 2014 and submitted my first Cairo paper in 2015 after a long time spent on a study that I believe was new and would yield very interesting findings for the interaction with objects and data. It was a comparative study, and the results were that the differences between each of the three conditions I tested for were quite small overall. It was surprising, and I was very happy to get such a surprising set of results for my first paper. I was, of course, very disappointed to get the results of the reviewing process telling me that the paper was rejected. Overall, the manuscript was rejected 6 times, and I almost gave up on submitting it after a while. I just put it online as a preprint and left it there for a while. Most of the time, the reasons for the rejection were that the results were not interesting or sexy enough to warrant a publication. Eventually, though, with a fantastic team of colleagues and supervisors, I somehow learned from this and managed to better explain and detail in the manuscript why the results were surprising and therefore very interesting for the community, despite the fact that the differences were pretty small. The paper was eventually accepted and then presented at Cairo 2017. So what did I get from all of this, and what is my message to you about this experience? I guess there's a couple of things. The first one would be that although peer review is essential to the scientific process, it is not a perfect process. What was deemed to be not so interesting and not very sexy turned out to be my most cited paper today, and I would tend to say that it does quite well in terms of usefulness to the community. The second thing is that from all of this, I actually started diving down into the publication of negative results and how difficult it is, and I started questioning and then contributing data and ideas to make progress in our methodology in HCI and VIS, but also in research in general, in particular looking at statistics and the communication, but also about the peer reviewing system in general. And although one can argue, and I still do, and I had in the past, that peer review is flawed, and then the content of my paper didn't really change from the first submission to the last one, because the data was still the same, I have to admit that I actually eventually wrote a much more convincing paper out of this long succession of failures. My first version of the manuscript was not as convincing as the version that is currently accepted. So the peer reviewing system did help me in getting a better paper out there. That being said, I'd be happy to talk more about the publication of negative results and why we should not even consider results in such a dichotomous fashion, because I made this one of my research topics. So feel free to hit me up if you want to talk about this. I'm really looking forward to all the exciting talks and discussion that we will have today. Thank you very much for joining my workshop.
Everyone, my name is Paul Rosen from the University of South Florida, and today I want to talk a little bit about my experiences with failure and how I use that to help prepare my students for the inevitable stumbles along the road. So at every stage of my career, I've struggled. As a graduate student, I of course struggled with papers. As research faculty, I struggled with papers, I struggled with proposals, I struggled with finding a tenure-track job that really fit me well. What this really led to was a 3-year cycle where I wanted to quit at these pretty regular intervals. I never executed on quitting academia, but I certainly had these feelings like I wanted to every 3 years or so. As tenure-track faculty, one of the things that I've really focused on with my students is trying to help them manage the ups and downs that come along with these various challenges. And so I just wanted to talk about some of these very briefly with you today. So the first some perspective on the problem. The process that we have in the US of having a 5-year PhD or a 6-year PhD means that the stakes are pretty high for all the conferences that you go to or all the proposals you submit. If we're talking about conferences, you get 5 shots at VIS at most. And then that comes along with the idea that paper acceptances to a conference are really a scarce resource, as are proposal acceptances, as are jobs. So if you think about it, 25% of papers getting accepted to VIS really means 75% of papers that get submitted are not accepted. And since we're competing against really talented people, it actually says a lot that you make it into that 25%. But it also says a lot if you're still in that bulk of 75%, because you are still, again, competing against some really good people. The other thing to keep in mind is that the outcomes that we see don't necessarily match with the reality of the merit of the paper that you're submitting. So if we charted merit against submissions to a conference, what we're going to generally see is something that looks like this green line. There are going to be a few papers that have really high merit, and then the majority of papers are going to have this sort of slow reduction in the merit. And honestly, there's going to be a lot of noise in the measurement of this merit. What the process we have of only accepting 25% of papers does is essentially it gives us this step function where we lump a whole bunch of papers into this group of papers accepted, and we say all of these have high merit because they've been accepted to IEEE VIS. And then everything else gets dumped into this category of papers rejected, and all of the stigma that comes with having your paper rejected. But the reality is that this is a very noisy function, and so even just a little bit of wiggling of this function, and maybe you would have been in that group that was accepted. So what I like to do with my students is I have a few strategies that I apply to them and I use with them, and the hope is that these help to soften the blow, because the blow is coming inevitably. And so the first strategy that I use is to basically reframe the goal of paper submissions, trying to make it less about getting the paper in or not, and trying to make it more about getting feedback for the work that we're doing. That only works to a limited extent, of course. Another thing that I push really hard is learning to identify and discuss the weaknesses in your paper ahead of time. To me, this is honestly one of the most important things. If you can identify all the things that reviewers are likely to find flaws within your paper over, you're going to feel a lot better when they come back not having accepted your paper. Next strategy is to plan for rejections. And what I mean by that is to basically know what you're going to do if your paper doesn't get in. I submitted my paper to VIS and I haven't thought about what the next submission is if that paper doesn't get accepted. If that paper doesn't get accepted, I'm going to revise it and send it here. This ties in really well with learning the weaknesses of your paper because you can even plan on what the next piece of work you're going to do to strengthen your paper is. And then finally, there's the old risk mitigation strategy, which is have more irons in the fire, more papers, more proposals going at any given time. And if you do that, your rejections will have less overall cost associated with them. So my quick closing thought is this quote from, I believe, Joel Daniels, who was one of Claudia's students many years ago. And the quote is, "A paper submitted is a paper published somewhere." The idea being that once you get it written, if you keep at it, that paper will eventually appear. And so keep with it.
Hi there. My name's Jordan Crouser, and I'm an assistant professor of computer science at Smith College. I'm going to spend just a couple minutes talking about what I think is sometimes the last frontier when we're talking about failure. And that's the value of failing where other people can see it. So a little context here. Smith is a small, historically women's college in New England, and I have the privilege of regularly teaching the first course in our computer science major series. So this course is often a student's first exposure to computer science and to programming, and many students walk into that class on the first day really unsure whether there's a place for them in the computational sciences. Most don't see themselves reflected in any pop culture ideas of what a computer scientist looks like. And if we're being honest, seeing me up at the front of the classroom doesn't do a whole lot to dismantle those stereotypes. So in that context, there's this myth that people who are good at something never make any mistakes, right? Good programmers don't get syntax errors. Their algorithms are always efficient, and they're able to get it right on the very first try every single time. So here's the problem. If we buy into this myth, what happens when you take the contrapositive? If people who are good at something never make mistakes, then people who make mistakes must not be any good at that thing, right? Whether that thing is programming or writing papers or grant writing or anything. Now, most of us here today probably don't believe that, right? We'll talk about the importance of failure in design and in refining an idea and exploring new territory, in building character and all of those things, and those are all true. But remember the context in which I do my work. Sometimes the most powerful thing that I can do is fail where my students can see me. When a student asks a question in class, for example, about how some function in Python works, and I pull up some IDE and I start coding off script, right? That is an open invitation to public failure. Invariably, I'll make some typo or some stupid syntax error, something will go wrong. That's why so many of us shy away from live coding in class or live demos during a conference talk, right? It makes us look foolish or unprepared or whatever. It also makes us look human. One of my favorite stories to tell my advisees when they're stressed because they're applying to grad school or jobs for the first time, I tell them about the first time I applied to PhD programs. I was resoundingly, unequivocally rejected from every single school I applied to. In fact, the first time I applied to a tenure track job at Smith, same story, right? It happened here too. Got a phone interview and that was it. And yet here I am, right? Sometimes failures are just failures. They're not always reflections of some deep, irreconcilable flaw. Right? At worst, they're just temporary ineptitude. Many more are bad timing or bad luck. It is true that there's incredible value in experiencing our own failures and in having help to learn to take those failures in stride. It's also true that when we're more forthcoming as a community about our big failures, when we document those and we share lessons learned, we make it easier for other people to avoid making those same mistakes, and we advance science more efficiently. But I think the idea that the end goal of all of this sharing and all of this scaffolding of failure should be to eventually eliminate failure is pretty suspect. Failure is inevitable, and those failures are not bad things. They're opportunities for connection and for commiseration. The big ones are evidence that we're taking risks and we're exploring things that are challenging and that are new. The goofy ones make us laugh, and all of them are evidence that we are human. So I'll get off my soapbox in just a second. But when you can, and not all of us can all of the time, right? I'm going to openly acknowledge the position of privilege from which I'm speaking right now. But when you can, try letting someone else see you screw up. Don't hide it. Don't cover it up. You might be surprised how much it means to the person watching to know that they're not the only one who ever makes mistakes. Thanks so much for listening.
Next up, we have a presentation from Leilani Battle on an incredibly helpful template that she has developed for processing and responding to VIS reviewer comments. Dr. Leilani Battle is an assistant professor at the University of Maryland, College Park, with a joint appointment in the University of Maryland Institute for Advanced Computer Studies. She is also affiliated with the UMD Human-Computer Interaction Laboratory, and her research interests focus on developing interactive, data-intensive systems that can aid analysts in performing complex data exploration and analysis. We will share a link to this template in the chat. Feel free to copy to your own drive and use this great resource in the future.
Hi everyone, I'm Leilani Battle, an assistant professor at the University of Maryland College Park. I'll be talking today about a template I created for tracking paper reviews and revisions. So at the top here, we see the document, the template, and it just has instructions about how to use the template if you're not watching the video. I'm just going to scroll down to the bottom, which is where you start using the template. So at the bottom here, you see reviews from PCS/CMT. These are just conference management systems that people use to submit their papers. PCS is common in visualization and human-computer interaction research. CMT is common in database research. And then there are other ones too, like EasyChair. Honestly, you can use whichever you want. They all still apply to the template. So at the bottom, we see we have sections for the summary review as well as the reviews of individual reviewers. Here you see there's space for 4 different reviewers. If you have 5 or more, feel free to just copy paste one section for a particular reviewer to make more. The idea is that you want to keep track of which reviewer provided which review, what score they gave, and in general what the summary was across the entire set of reviewers, what the sentiment was for the paper. So for example, if your reviewer has an ID R1, you would just put R1 here where I've highlighted. And if they give a score of 3.5 out of 5, you would put that here as well. And this is just so you don't have to go back to whatever conference management system you use to submit your paper and to get the reviews. It's just helpful to keep everything in one place. So once you've copied and pasted everything verbatim for each reviewer and for the summary review, of course, you're going to read those reviews and extract insights on what you would want to do to improve your particular submission. That's what the next section is for here, and it's called Summary of Concerns. So the idea here is that you're taking the content that the reviewers provided and synthesizing it into useful information that you can actually act on for a revision. And the important thing here is to acknowledge, right, that reviewers are human beings, right? We do great things, but we can also make mistakes. We also might not say things in the way that are most supportive for the people who submitted the manuscript that we reviewed, the submission that we reviewed. So the idea here is to take what you can that's useful or productive from the reviews, synthesize them into main summary points that can be used for your revision. So you'll see here a section for each reviewer, similar to copy pasting the reviews from the conference management system below. And the idea is for each reviewer, you read their review, you identify 3 to 5 major points of concern that that reviewer had, and you paste it, and you write those here in your own words. Do not take quotes directly from the reviews and assume that that is enough to cover a high level point of concern. The idea is that you want to make sure you're on the same page with what you believe the reviewer is trying to say. And to test that, you just write it in your own words. It's fine if, in addition to that, you want to include quotes that kind of capture what your summary is meant to represent, but do not use direct quotes as a main concern point. I highly recommend against it. So of course, for each of your reviewers, you want to write 3 to 5 points. And then once you can see all of those points together, that's when you're going to use this all reviewers summary of concerns. So the idea is you want to create a consolidated list of concerns. Oftentimes, reviewers will say basically the same thing for certain concerns, and it really represents one concern, not 2 concerns. So what you can do is write that concern, say, this is the first concern in your list, just put it here. And then you can also include in parentheses, which you see here, the number of reviewers who shared that particular concern. And this is really useful because I use it as a coarse way of tracking the significance of that particular concern. For example, if every single reviewer mentions that concern in their review, that's probably a significant issue in the paper that needs to be addressed. Whereas if just one reviewer mentioned it, you want to satisfy all of the reviewers when you can. However, if only one person said it, it's not as important or as critical as something that all of the reviewers have an issue with. That being said, it's not just about quantity, it's also about the quality of the points as well. So if one particular reviewer, even if they were the only one who said it, maybe they were the lead expert in reviewing the submission and they had some really good points. It's possible those are important too. Use your own best judgment in terms of the ranking, but a coarse approximation that tends to work pretty well for me is the more reviewers mention that particular point, the more significant that point tends to be in terms of addressing it or a revision. So we've talked about summary of concerns, which summarize the main takeaways from the reviews, which we copy paste at the bottom of the doc. Now we continue to move up to the revision plan and the revision letter draft. So what the revision plan is for is to propose and keep track of, point per point for the summary of concerns, how you want to address those concerns in your actual paper. So at this point, before you've written a revision plan, you haven't made any changes to the paper yet. And this is great because it allows you to do all of that tracking of all of that work all in one place in this document. It's also great too because if you're working in a team, all of the reviews are in one place. The team can comment on those reviews if you use Google Docs, for example. So the entire digital conversation around the reviews can happen in one place as well. The summary of concerns can also be reviewed together and developed together as a team. And then the revision plan, everyone can have access to it. They can see how exactly it connects back to the summary of concerns and the reviews all in one place. So with the revision plan, just my recommendation is point per point for each of the major concerns from all reviewers here that you write. Just point per point, come up with a list of revisions that you want to make for your paper and try to order it in accordance to the prioritization that you put in your all reviewers summary of concerns, because then you'll know, okay, this revision, this particular proposed revision is pretty significant because it's towards the top of the list. And we know that things towards the top of the list tend to match up with some of the most important concerns from all of the reviewers. So if you keep things consistent in that way, it's an easy way to gauge, okay, am I really working on the most important revision that I should be working on for this particular paper or not? And I highly recommend for each revision point, if it's point per point with the reviewer's major concerns, you might as well also just copy the list of reviewers that revision is meant to address, because then you can use it when writing a revision letter draft. So typically, if you're lucky enough that your paper was accepted or a revision was requested, then the reviewers are going to expect that you're going to tell them exactly what changed in response to their reviews. And this is where the revision letter draft can be really helpful, and the revision plan together. Because what I like to do is, as I go through and execute my revision plan, I'll just put in a sentence or two as I complete each revision, a sentence or two in my revision letter draft here, how I addressed a particular concern from the reviewers. I'll put in the list of reviewers who mentioned that concern. And in that way, I can kind of write the letter as I go. So I just want to say, as a caveat, not all reviewers like this format. This format is very Kai-like, I would say, because with a rebuttal, you have to be a bit more space conservative. So summarizing concerns, listing the reviewers who shared that summary of concerns, that's very common at Kai, but for VIS or other conferences, they may prefer something more detailed. So just keep that in mind. For example, at VIS in the past, we have been asked to address the exact points of every reviewer separately. It's not the most space efficient way to do things, but when space is not an issue, the revision letter drafts can get longer. So just keep an eye out for that. But as far as personal internal organization, I love this format because it makes sure that I work on the most important things first. All right, so that's everything. We talked about the reviews, copy pasting them from your conference management system that you use to submit your paper, filling out the summary of concerns for all reviewers, and then summarizing across the reviewers, coming up with a revision plan that matches the summary of concerns, and then also the revision letter draft. Thank you so much for listening to my spiel about the template, and I hope it's useful for you in the future.
Thank you so much to Professor Leilani Battle at the University of Maryland. Her invaluable template has been posted to Discord, and it should also be available in the YouTube live stream chat. So if you think that would be useful, shout out to Leilani. Thanks so much for sharing. So up next, we have our panel discussion. Our panelists will be Kristen Cook, Alark Joshi, Stephanie Evergreen, and Alberto Cairo. It's a slightly unusual format given the time zone issues that we had. So we conducted mini interviews with each of our panelists, and we've spliced them together into a sort of reasonably cohesive panel discussion. At the end of our panelists' remarks, we'll be rejoined by a subset of them for a Q&A. So I will ask our technicians to roll that video. Hi there, this is Jordan Crouser. I'm an assistant professor of computer science at Smith College in Northampton, Massachusetts, and I have the pleasure today of speaking with Kristen Cook at Pacific Northwest National Lab. Hi, Kris. How are you today?
I am great. Thanks for asking me to participate.
Joining me now is Dr. Alark Joshi. He's an associate professor and the department chair of computer science at the University of San Francisco. Thank you for joining me, Alark.
I cannot believe that my first VIS conference was in 2004 in Austin. Overall, I'm just delighted to participate in this panel at FailedFest this year.
I'm joined today by Dr. Stephanie Evergreen. Dr. Evergreen is a data visualization and design expert. She has trained future data nerds worldwide through keynotes and workshops for Fortune 500 companies like MasterCard and Facebook, and mission-aligned clients like the United Nations, the Boys and Girls Club, AARP, and the Alaska Native Trial Health Consortium. She has written 3 books and a popular blog on data visualization. Thank you so much for joining us today, Stephanie.
Awesome. Thanks for having me on this panel.
So I have the pleasure to be with you today, Alberto Cairo. You're a Knight Chair in Visual Journalism at the School of Communication at the University of Miami, right?
Yeah, correct. That's correct.
What does failure look like in the context of your work?
Now, as a researcher, we always think of success, failure as a binary concept. Actually, failure is just a construct that we have defined for ourselves. If a paper or a grant proposal is rejected, we think of it as failure. I have had rejected papers go on to win the best paper award at a conference. And so did I fail the first time around, or was it just a matter of addressing reviewer feedback and resubmitting the paper?
I define failure when what you attempt to do through a visualization is not successful, right? So you have some sort of like goal in mind, some type of information that you want to convey, some sort of task that you want to enable readers to achieve, or simply you want to bring people's attention to some sort of data. And then what happens is that you basically design the graphic, you present it to the public, and it fails completely at achieving those goals. Or maybe because it fails also in the sense of ethical standards, right? Sometimes, I mean, there are people out there who design graphics, let's say, to mislead the public, to lie to the public. And maybe the graphic succeeds at lying to the public, at misleading the public, but I would still call that graphic a failure, just because the intentions that the designer had were misguided or were wrong, completely ethically wrong or morally wrong, right? So that would also be a failure in that sense.
Yeah, so in my work as a designer, I would say failure shows up when I'm producing a work that doesn't meet the needs of my clients. In my work as an author, it shows up in like printed mistakes, like actual factual errors, and more increasingly recently thinking more about my word choices. And in my work as a data viz trainer, it shows up usually in like forgetting my talking points or mismanaging my crowd, which is like a totally different skill set than we often think about with data viz.
What does failure look like in the context of your work at PNNL?
So failure, you know, a lot of times when we think about failure, we think about an experiment that didn't produce the kind of results that we expected. But that's not really what we define as failure at the National Lab. For us, failure is missing the mark on trying to solve the wrong problems, or it's failing to be aware of what the state of the art is and reinventing the wheel. So failure is less about whether or not a well thought out experiment comes out the wrong way or comes out in a way you didn't expect. And it's much more about a failure of process and critical thinking in terms of whether you got to the right place or not.
Do you have a personal story of visualization failure that you think others might benefit from hearing?
Oh, do I have a personal story? I have many. But for this question, I'm going to answer by talking about work I did during my PhD. I worked with atmospheric physicists to visualize hurricanes. Working with domain experts was extremely satisfying and challenging all at once. Watching them find interesting insights in their data based on my visualizations was super fun. One of my research papers based on this collaborative work was rejected 3 consecutive times during my PhD. I was freaking out. We finally submitted it again to TVCG, and after a round of reviews, it was finally accepted. And that felt awesome.
So thinking back on like the first big failure of your career, was there any advice that you wish someone had given you, or something that you learned from that experience that you'd like to share with us?
Oh, absolutely. You know, I had joined the team as a new project manager for some of the work. And so as I was getting my feet on the ground, I was getting to know our sponsors, our users for the software. So I remember very distinctly going out and visiting some of our users and having this really great discussion about the things that they needed to see next in the software. And in fact, our sponsor had some very clear and well-rounded ideas about what kind of problems they needed to solve. And I, in my newbie confidence, was, no, I think we should do it this way instead. The sponsor just kind of smiled and let me go off and lead the team while we did it my way. And 3 months later, I was back in the sponsor shop and discovered that my way was completely wrong. And he very gracefully never said, "I told you so," and gracefully let me say, "You know, I think we should do it this other way," and go back and do it his way. And sure enough, he was completely right in terms of understanding what they were actually trying to do and what we needed to try and solve. And that was very different than my preconceived notions coming from the research side. So the lesson that I took away from that is the importance of listening.
The more that we listen to our audiences, the better off we're going to be. And I think we often skip that step because it takes a lot of time. And we're in this current state of the world where the pace just feels breakneck, and that we're going to have to move a lot slower than what we're pressed to do these days if we're going to make the space to get it right.
Why is it important to share stories of failure within the VIS community and more broadly?
In my opinion, it is extremely important to share stories of failure because all we see around us are success stories, either in the form of best paper awards, most cited papers, test of time awards, and so on. Hearing about the struggles and disappointment of top researchers in the field has truly given me the motivation to keep working hard. Given how young the field of data visualization is, it would help us all to share our failed results so that we can save other researchers time and effort to pursue those lines of inquiry.
Showing just successes is counterproductive. Because just think about, the people who we consider widely, the best visualization designers in the world, right now. All the work that we see from them is the work that succeeded, right? The most viewed work or the most popular work. And that conveys the very misleading idea that those designers can do no wrong. But if you talk to those designers, they will always tell you, out of 10 projects, probably one I really feel proud of. And that's, it's the same thing with my work. I don't design a lot of graphics these days just because I focus my career mostly on teaching and writing and reading and thinking. I still do some design work, but not as much as I used to. Let's say in the period between 2000 and 2010, in that decade, I made tons of graphics. And I think that I can count with, 10 fingers, the ones that I really think, this was really good. This was really good. All the other 99% is just, bread and butter graphics that were published or things that I really don't feel that proud of. It's just graphics that sort of accomplish their goal and nothing else. And I think that it is worth discussing all that part of work just to show particularly beginners, right, that it's fine to make mistakes and it is fine to learn from those mistakes. And it is also fine to discuss those mistakes in public. And I've done that in some talks. I have criticized my own work from 5 or 6 years ago, or 10 years ago, and I wish that 10 years from now I will also be able to critique part of the work that I'm doing nowadays. I think that is part of anybody's career, to be open about the fact that we are all human, that we all make mistakes, but at the same time that we are also open-minded enough to receive feedback from others, honest and gentle critique, obviously, from others, not aggressive. I'm not a fan of aggressive critique, but if we receive gentle, honest critique from others, to receive that critique with an open mind and try to adapt your work and change it and improve. That's how we improve, right?
What advice do you wish that someone had given you when you experienced the first major failure of your career?
I heard this advice actually recently and wished I would have heard it earlier, but the advice I heard was minimize your mistakes. And I think it's great advice because it means you're going to make them. It's not some shiny mistakes don't happen. No, it's you're going to make them. Try really hard not to. Be a good person, do your homework, do your research. But despite that, despite all of your preparation, you're still going to make mistakes. So I think that can be incredibly helpful for us. early on in my career, I was working at a place where the culture was like overconfidence and also this like over reliance on grad students to do all the work. So mistakes happened all the time, but like you weren't allowed to say it, you weren't allowed to admit it, and that became a super unhealthy environment for people. So the person who gave me that phrase, minimize your mistakes, is Indigenous. He's Cherokee. And we were discussing white people trying to do anti-racist work, and that was the advice that he gave in that context: to minimize your mistakes. Do your very best not to make them, but understand that they're going to happen. That's just life.
Right. Life is messy. And I love
Exactly.
the, design thinking approach similarly, to fail early, fail often.
Yes, right? Iterate, get better. And the more you do it, it's kind of like trial by fire, right? Like the more you go through it, the easier it gets. The first few suck, it just gets better after that. So, I mean, don't get me wrong, I don't just like walk away from a mistake and go, like I take it seriously, but doesn't send me in the corner crying for 3 days like it did when I first got started.
I wish someone had shared stories of their failure with me earlier in my career when I experienced failure. It was very heartbreaking, and it took a lot of internal struggles to get out of that hole. But I was glad that I was able to make it out. It is always a lot better than you think it is. There are always many options.
So I think it's incredibly important to share failure stories. I know in my own experience, given the fact that I've been at the lab for a good while. I've had a career that's, I'm definitely I'll be generous, in the second half of my career. But I feel as if it is my obligation to be able to share my experiences with my colleagues, with folks who are coming up, so that if I can save them any pain, if they can learn from my experiences, so that that's one less failure that they need to have on their own, then I think that's my obligation as a member of the professional community. Failure is a part of life. We all fail. We do our darndest not to, but it's part of my obligation as a professional to try to help share my experiences where they are relevant. Hopefully I don't turn into one of those, people telling infinite boring stories, but to share stories where they're relevant, so that people who want to learn from my experience hopefully can have a leg up and have some greater success and have more successes than failures, or at least have different failures than I did.
Could you tell us about a time in particular when someone shared an impactful story of their own failure with you? And what did you take away from that experience?
Yes. So I remember very clearly, this was years ago now, but I was in New York City in February. It was a blizzard outside my hotel room. And I was there on a Sunday getting ready to give a 2-day workshop at the United Nations. And I was buried in so much work. Like I was drowning and stressed out and kind of getting burned out. And I had just tried to hire someone to help me with this who had pulled back her availability at the last minute. So I was in a really tight spot, and I knew I was going to spend the next 2 days with a particular set of clients not doing the amount of work that I had to do. So I reached out to a mentor, someone who has a pretty high profile, and said, how have you done it? Like, how have you survived all of these years? You don't have a ton of staff, so how are you doing this without getting stressed out and burned out? And he was so gracious in his response. It was really, the gist of it was, I've been there. I've been where you are. And that in and of itself just helped normalize everything and make me feel like this happens to everybody, not just me. And it happens to people who have a large profile where it looks like they've got it all together. Nobody's really got it all together. Everybody is scrapping by behind the scenes. And the more that we talk about that, I think that the more we help everybody feel like it's okay. And I especially feel like that's a responsibility of people with higher profile is that the higher our profile goes, the more we're responsible for telling other people that it's not all shiny and perfect.
This is funny because I was talking to a colleague who is a successful professor at a top university. I look up to this individual and I was surprised and honestly shocked to find out that this professor had submitted somewhere between 10 to 12 proposals that year, and that only one of them was funded. I was dejected after receiving my first proposal rejection and was feeling low about that. And when I talked to my colleague, professor, this person, I figured that they would have a high success rate with no trouble at all getting their proposals funded. I came away feeling motivated and realized that I need to work a lot harder if I want to get my proposals funded. We all need to be honest with each other about the struggles that we go through, and it will only help our field grow stronger and sustain it for years to come if we do so.
In your paper on human factors in streaming data analysis that came out not too long ago, you identified a gap between the theory and the application of visualization that seems like it's sort of speaking along these same lines, right? Where real-world applications for the analysis often require this high situational awareness, but that same need is really underrepresented in the academic literature. So when success in research, in our research community in particular, has historically been defined by academics, how do we expand those definitions to better encompass the needs of our end users when they're trying to apply these tools in the real world?
So I think that's an excellent question, and it's one of the things that we try to address using the VIS challenge. So just as a brief reminder of what the VIS challenge is all about, every year since 2006, the digital analytics community has put out an annual challenge that basically provides some realistic problems that require not only data analysis, but human insight in order to solve. So these problems are in some ways they are smaller problems, they're more tractable in some ways than real world problems, but they have a real world practical flavor to them. And they allow people to get a sense for the kind of thinking that people need to do to solve these analytical tasks, not just from the software development standpoint, not just from the visualization research and development standpoint, but also, and I think this is very important, from the user standpoint. So a successful submission to a VIS challenge not only involves either creation or application of visual analytics tools, but it also requires participants to try to think like analysts and understand what kind of nuances might actually be necessary to understand in order to solve a real-world problem. That said, I do think there's still a really interesting challenge to be addressed. As we talk about the differences between research for the sake of advancing science versus research for the sake of advancing applications, there's a degree to which some of that more nuanced application-oriented work is not publishable. I think that's kind of a discouragement for academics to get as deeply involved in reducing things to practice. But I think we have found in multiple application areas over multiple years that working on toy data sets or working on very simple data sets is only the beginning of making a technique practical. And there's an incredible amount of really challenging work to be done that includes research work that's important to do by focusing on realistic data that is much messier, much more contradictory, and sometimes much more spotty and uncertain than we'd like to work with in visualization. So it gives us some really interesting opportunities to advance areas like uncertainty research and bias research, and in order to be able to try to tackle these problems.
Now, the primary tenet of team-based learning is to learn from your peers. Higher peer diversity leads to better discussions and better outcomes overall. I use team-based learning in all my undergraduate courses. Students learn by applying their knowledge in class on real-world problems. In a field such as data visualization, we could offer an interdisciplinary course at the university level where students from groups as diverse as computer science, design, psychology, and various domains could work together to learn from each other and potentially even solve a problem in a specific domain. Through the entire process, all the students will learn to work in teams collaboratively, and it will provide a great learning experience. This could even be scaled out and tested by using collaborative tools at multiple institutions. We are all used to Zoom and collaboration now. Creating the same course at multiple institutions may be challenging, but having peer-based learning, as I said before, across institutions, teaching data visualization could definitely be done. And with that, I'd like to thank you for your time, and I'm happy to answer questions.
Thank you very much for your time, Dr. Joshi, and we really appreciate your answers to these questions.
It's very interesting to talk to you today because you have this both like one foot in visualization research and one foot in journalism, and I think there's interesting bridges we might need to make there. For instance, do you think the visualization community should get interested in journalistic standards for visualization?
Yeah. As I said before, I am a great believer in like destroying silos and boundaries and just blend everybody together and create conversations and build bridges among people who have different backgrounds. And this doesn't include only visualization designers and visualization researchers, but also journalists and visualization researchers, journalists and visualization designers, cartographers and journalists. I think that we can all. By the way, one of the reasons why I like to do this is that it's based on my own experience. So when I was learning about design, I learned a lot about color, and I learned a lot about layout, etc. And then much later in my career, as I said before, when I started reading about cartography, I said, we are reinventing the wheel. It's like these people are writing about the exact same things as we are. So why are we reinventing the wheel? Why are we working in parallel? That doesn't make sense, right? Why don't we join forces and learn from each other? That will save a lot of effort and a lot of work. If these other communities are already working on these problems, why don't we engage with that community openly and just borrow ideas and then offer our own ideas to them, right? Obviously in return. So what we can learn from each other? I think that journalists, we need to learn more about the value of testing and UX research in general, right? I have a lot of mantras that I use in my own work, and one of the latest one that I repeat in conferences lately is very basic. It says, it will sound as a no-brainer, but it's actually not. It's like what you design is not what people see. What I said before about the mismatch between mental models, right? You design something following the rules, scare quotation marks in there, right? The rules of design. I said, this is going to work perfectly, right? And you create a great graphic following all the rules that you have read about in the literature, blah, blah, blah. And then you put it in front of the public, and the public doesn't get crap from the graphic. They don't understand what it is that the graphic is showing, right? So what I usually say is that there is no rule that resists the test against reality. So that's the reason why learning some research methods may be important for journalists, because the problem with journalists, though, is that we usually work with very tight deadlines. So it is very hard for a journalist to sort of like plan for research part of the process that lasts for 2 months. We cannot afford that, right? But there are still certain methods that can be applied in a very short time, right? You can still do, small focus groups. You can still do some sort of like series of semi-structured interviews with people who you believe that may be a representative of your public, right? You show them the graphic, you let them read the graphic, you return to them a while after, and you ask them, you begin the conversation with, what did you learn? And you have them speak about what they learned. You can extract a lot from that, right? From that conversation, right? That's sort of like a very essential, very basic qualitative method of research, right? Doing some sort of like semi-structured interview. Those kinds of things can be used by journalists. And I wish that we could learn a little bit more about that. And then on the other side, journalistic techniques or teachings being borrowed by other communities, I also say yes. And regarding ethics, for example, one of the ideas that I had for the past few years is that the essential ethics of journalism, right? Trying to be fair when you communicate something, trying to be balanced when you communicate something, trying to be honest, trying to double check and to verify what it is that you're going to be presenting to the public. Things that every journalist should apply. Ideally, that will be the case, not always the case, but ideally those are the rules of journalism, right? Try to be fair, try to be honest, double check, verify, and so on and so forth before you make something public, right? I think that those are not journalistic rules anymore. I think that those are sort of like civics rules or like they are rules of civic behavior, considering that nowadays everybody with a social media account is essentially a journalist because we all put information out in the public, right? Now, researchers, obviously, they do this ideally already just because you're submitted to peer review. So someone is going to double check and verify what it is that you're going to publish. But that is when you publish academically, not when you publish in more sort of like open or non-structured platforms such as social media platforms. I wish, for example, that the people who are reading about or who are writing about the ethics of data will read a little bit more into the literature of the ethics of journalism, because I think that there are bridges to be built between those two areas, right? Some themes that appear in one literature also appear in the literature of the other field. And I think that there are many, many topics, many themes, and many things that will be borrowed from each other. That's another area that I'm interested in sort of like helping build bridges in ethics and moral reason.
What kind of failure stories do you think are most important to share? For example, failed experiments, disproven hypotheses, technical challenges, publication struggles, or failure for theory to match practice?
In my opinion, we need to share all kinds of failure stories. In my eyes, they're not even failure stories, they are just experiences. For junior researchers, we must show that failed experiments and disproved hypotheses are just a data point that we learn from. Hypotheses being disproved is a part of the scientific method. And so there's definitely no failure there. And I'm delighted that we have Failed Fest for members of the VIS community to share these stories with the larger community. Technical challenges are also extremely important to share. Sometimes it can help students and junior researchers realize that it takes a long time to get to a point where something is publishable, and that excellent quality takes time. Attention to detail is necessary for success, and honestly, there's no alternative to hard work.
When we're taking on so much in our practice, especially for early career researchers in our community, the tendency is to always want to say yes to every opportunity that comes along. But do you have any kind of tips for triaging, like when to maybe say no or to delegate tasks?
Yeah, so I mean, I've talked about this before, but my rules for taking on clients are 3. It's fun, lucrative, and no assholes. Those are my 3 rules, and they've worked really well. I didn't make them up. I just got them from my mentor, who I believe got them from her mentor as well. But those are my kind of criteria. So if I don't have all 3 of those things, it's going to be a no. And I think that can help because I was in that place too. Like when I first started out saying yes to absolutely everything and just thinking, especially as a consultant, you never really know where you're going to be in 6 months. So you just sort of feel like you have to say yes to everything. So I think we have to make really good, judicious decisions about when it's going to be worth it and when it's not. So the earlier you can come up with some client criteria, like the stuff that's going to make it a yes for you, the better. And I would try to hold firm to that. And also there's a bit in there of just need to trust the universe, that more things will come even if you say no to some things now.
In your experience working at a national lab, you're often developing long-term projects with many different stakeholders. So how does your team build iteratively to be able to account for potential failures, whether they're a failure of the product that you build or a mismatch between the expectations of different stakeholders? How do you accomplish that?
Well, there's a couple of things that I think have become hallmarks of our approach. First of all, even from the earliest stages of exploratory research, we want to be informed by user problems. So we do a lot of workshops with users, and we try to be very careful about what those workshops look like. So we are not interested, when we're doing research, we're not interested in the nuances of how particular approaches work today, but we're interested in what the big problems are, not in terms of the logistics of one or another particular tool, but in terms of what are the big goals that people are trying to address. So we have to start out by being really grounded again in those problems. Once we've got that grounding, then we're in a lot better place to be able to start trying to explore research ideas that can help address what those fundamental challenges are. So iteration is really important in two ways. So one, we are iteratively talking with sponsors, talking with users to understand what the problems are. The other thing that I do want to interject, though, just as a sidebar, is that you never stop paying attention to the state of the science, though. Things move very quickly in VIS research. Things move very quickly in the commercial world right now. We have to stay continually aware of what new innovations are available, simply because we need to ensure that we're being really good stewards of the government's money. So it's important to remember that as a national laboratory, our goal is to fill a niche or fill a role that is different from either academia or industry. So we try to address those problems that are first of a kind or one of a kind problems that maybe get more applied than academia might typically focus on, but also that address different kinds of needs than industry might already address. So it's a really important balance for us to continue to be aware of what's going on in other communities so that we can bring the current state of the art there to bear rather than trying to, again, reinvent the wheel.
Some research communities are open to publishing failed experiments, while others tend to focus exclusively on positive results. Where do you think the VIS community falls in that spectrum? Is that something you'd like to see change?
The VIS community very rarely discusses its failures. It is cute to post pictures on Twitter and use the hashtag D3 broke and made art. But I would like us all, students, researchers, senior professors, to discuss our failures in any manner that we are comfortable with. It could be something as simple as a Medium blog post, or even a tweet or a research paper where they catalog their experience. Now, we need to be honest and open if we want our community to grow and feel welcoming to new students, researchers, and collaborators. With regard to failed experiments, I think our incentive structures do not encourage us to share them. We need a reputed journal or some similar highly respected venue to share our failures. There's a stigma associated with failing in academia, and given that many of us are educators, we should know better than to view failure in a negative light.
I cannot speak about with any authority about this itself. So, but in the community, I think that there is an openness to sort of like talk about failures here and there, or at least there is an ongoing conversation that in which many people are involved in terms of like improving oneself work and giving feedback to others, right? When you think about, the Slack channel of the Data Visualization Society, or the Makeover Monday community, or storytelling with Data's website that has forums in which people can share ideas and contribute and critique each other in a gentle manner. That type of conversation, I think, in the community is absolutely essential, because again, one of my main beliefs is that knowledge doesn't reside in single brains, right? Knowledge is distributed. Knowledge is networked. So it's impossible for me to know everything about visualization, no matter how hard I try. It's impossible, right? There are people who know much more than I do about visualization theory, or about cartography, or about anything, about color theory, about design, about layout. So it's incredibly important that a channel or several channels exist in which I can design something and then put it out in the open and seek honest feedback from other people in order to improve it. What do you think about these? Right? You show your work to others, and then you expect from them some sort of like gentle, kind, and helpful and constructive critique. The same way that I provide that critique to others if I am asked to. Right? Honest again. I try to be as honest as possible, but also I try to be as kind as possible as well. I'll try to be constructive. Say, this is complete crap. I never say that, right? But I can say very forcefully, I think that this is not going in the right direction, and I think that you should do this the other way. And these are the reasons why I think that this may work better. That type of feedback is essential in our community. We should be open to provide it, and we should all be open to receive it, because what matters to distribute the knowledge more effectively is that this conversation is fluid and open, and there are no gates to it.
Stephanie, you've authored many articles and books that address the topic of failure in visualization and scientific communication, and they are, in a word, delightful. When we talk about failure, it seems critical that we find a way to laugh at our own mistakes, to make light of the learning process and to kind of humanize that process. So I was wondering if you could share your thoughts on the role of catharsis and that tone of humor in sharing our stories of failure.
Well, for me, I think humor is probably my superpower or my defense mechanism, or both. Maybe it's both. But especially in scenarios where we're thinking about failure, I think it's really important for us to make the response proportionate to the problem. Failure can feel huge. It can feel monumental when, in the grand scheme of all of the things that you're going to accomplish in your life, it's probably quite microscopic. So I think failure is such a huge, massive elephant that we like to shove into the closet. But when we bring some levity to it, when we can make a joke out of it, when we can laugh with others about it, and laugh with, not have them laugh at, then I think it right-sizes failure and makes it feel like something that we can more easily handle and then move on from.
Stories humanize the struggles and pain associated with the failures. Whenever I talk to my mentors or colleagues and hear about their struggles, I realize that everyone goes through struggles in different ways, and that they come out of it wiser and better prepared. Even as a grad student, I wondered whether I was the only one going through these struggles and challenges associated with coursework, publishing, and personally even with loneliness and frustration. But when I got involved with the Graduate Students Association, I realized that almost all grad students were going through the same issues, and it wasn't just me. Honestly, I was just relieved, and it made me feel a lot less stressed. Seeing others go through the same process and get jobs in academia or at research labs made me realize that I can do it too.
Hi, everyone. Thanks so much for joining us, and thanks to our panelists for some just amazing words of wisdom there. So I'm here with Alark Joshi and Stephanie Evergreen, two of our panelists, and I'm going to be taking a few questions from Discord and YouTube. Feel free to keep them coming. I think I'll start with a question from Shivam Agarwal. Shivam writes, sharing failure stories or celebrating failures has a positive effect, but it's also important to constructively reflect on the reasons of failure for personal growth. Sure, not all failures have a reason, and some failures might occur due to reasons beyond our control. My question is, what are the good ways to reflect on the reasons for academic failure, a rejected promotion or a position, etc.? Do the panelists have any tips for kind of reflecting on the why of a failure and growing from that?
I mean, I can go first. I think one of the things that you should consider is whether there is some possibility for growth, and is there something that you can learn from that failure. One of the major challenges sometimes is trying to kind of tie your own value with a project, and you should kind of think of it as, okay, this is a project and this is me. It's not that you failed, it's that there's something that has happened with this project, and kind of deal with that in a slightly clinical manner. In many ways, I think you have to decouple whether something wasn't ready and that's why it failed, or whether there was some element of chance associated with it. And the last thing I'm going to say is, having been a reviewer as well as a program committee member, I know how the sausage is made, and that's all I'm going to say.
Well, I'll add to that. I think those are great. Those are great ideas. The decoupling, I think, is super important there. But yeah, just to add to it, first of all, I think that the personal learning, I think, happens almost immediately for everybody. I mean, I think everybody is so self-conscious that if we failed, we already know what it was that we did wrong, and we have to take it a little bit too seriously. I mean, I think that's just kind of the nature of the game. But we have at Evergreen Data a little bit of a project review at the end of whenever we finish something, whether it was great or whether it had some kind of conflicts in it, where we diagnose our lessons learned. And I think it's just as important to do that when something's gone right as when something's gone wrong, because everything is going to be a learning experience for us.
Great, thank you. So our next question comes from Shahid Latif, saying PhD students early on in their career, and I'm going to generalize that to people early on in their career, often see rejection as a failure because it has high stakes, right? You're sort of establishing yourself. I'm wondering what, as a community, we could do to decouple the paper rejection process or a client didn't like what you did process from failure of a project or failure as an individual.
Stephanie, why don't you go first?
I'll take it first, sure. Yeah, I mean, I think that that doing stuff just like this, making a FailFest a part of a conference, is absolutely critical, because this is where we normalize that this is something that happens to everybody all the time, at every point in their career. I think it's actually the responsibility of the people who have been in the field for a while to the lead and talk about the places that we failed, even today, not our early career failures, but the ones that are ongoing on a regular basis, so that we can just establish that this is something that you're going to survive, that's going to happen to you, but you're also going to survive.
Yeah, I mean, I'm just going to echo Stephanie's comments and say that, I think going through a PhD is obviously very stressful. It should be your advisor's job to give you some context about that and also share their past failures as well as their current failures. I think I've seen some fledgling kind of attempts where people post their either failed rejected reviews, or even process of like NSF career proposals where they've submitted one, got it rejected, submitted it one more time, or maybe twice and got it rejected. So you kind of see the review process, and you can kind of see if they're making what kind of changes they've made. I think we need more of that with papers, even that, so we can see that, okay, papers that you think are amazing and are like fantastic papers, they've also been rejected in the past, as Lonni mentioned in his talk earlier.
Great, thanks. I'm gonna try to combine a couple of questions that I'm seeing that I think have a common theme, which is VIS specific. So in the VIS community, probably in research communities at large, we have a tendency to really, really amplify the winners, right? So if your paper wins an award, it gets tweeted all the time and you get extra time for your talk and you get a nice little certificate, right? But we don't do that for the failures that we learn a lot from. So what levers could we pull as a community? You know, having a workshop is great, but it's sort of contained in time. What would need to shift from either of your perspectives to transform us into a community that amplifies the learning from failures as well as we amplify the learning from successes?
I only have a couple ideas about this, so I'll just go first. But I think one of the things that we could do is start, when we are publishing, add in some kind of citation about how many times we had R&R before this thing got accepted, you know? Like, I think we start to see it now where people will, part of the publishing process, when you see an article, it'll say like, it was first submitted on this date and then finally accepted on this date. But I think if we could go even further with that and say like, how many iterations this thing actually went through before it made it here. I know that's still kind of keeping a highlight on the successes. I'd love to change the academic publishing industry so that we didn't just promote those successes, but I don't think I'm that powerful. I'd love to see the same thing for, VIS published in general, that when we see something on the web, we start to also see how many times we redesigned this thing before we landed on the final product. And I believe we actually are beginning to see some of that. We're starting to see some people who are giving us a behind the scenes tour of their VIS making process. And there's a lot of interest in what that process looks like. And I think that's where people are also like starting to have those conversations. So let's just do more of that too.
Great.
Yeah, I'm just going to echo some of the same things, but I think like to me as an academic, I think that incentives work. And I think we need to change some of the incentives. I know we are talking about the revised proposal to change VIS and kind of think about different areas, and maybe we can have an area where we can share maybe results that are not, you know, statistically significant, you know, where we can share, okay, here we've spent 2 years trying and run like 5 different studies and we still don't have anything to show in terms of one technique being better than the other. That can help a lot of people who are maybe going to go down that path in the future. And so I mean, I think in academia, we are trying new things and we should, you know, just share our experiences, whether they are, you know, significant or not.
Thank you both so much for joining us today. I think that we are about at the break, and I know that everyone needs to get their coffee, even if you're making it in your Keurig at home. But claps in the Discord channel for our wonderful panelists today. Thank you so much for joining us, and we will see you back after the break. Bye, everyone.
Great. Thanks for having us.
The success of a convolutional neural network has been attracting many students and practitioners to learn the exciting technology. However, for beginners, the CNN model is not easy to understand. We introduced the explainer, an interactive visualization tool to help beginners more easily learn about convolutional neural network. Using the explainer, users can progressively explore the CNN model with real-life images in their browser, getting a comprehensive understanding of both high-level model structure and low-level underlying mathematical operations.
We present TransVis, a design study that is proposed to analyze and integrate close and distant reading of multiple translations. TransVis presents the overview of the collection to capture global patterns that is facilitated by the ADM-VIV matrix. TransVis integrates a detailed view to explore interesting path of alignments. We also propose the TLC view to examine and explore the terms of the user-selected path to justify and reason the AD analysis.
We present StratGraphics, an approach for designing data-agnostic and fully reusable visualization templates. StratGraphics follows the inverse workflow that common data-driven systems. Rather than starting from data, designers construct visualization structures without relying on a data schema. Data tables are shaped later from the structure of graphics. We demonstrate the power of the approach through a gallery of visualization examples.
The classifier trained on the historical data may fail to classify the incoming data when the data distribution is changing. This phenomenon is called concept drift. To handle the concept drift, we developed Drift VIS, a visual analytics system to help the expert understand when, where, and why the drift happens, and update the model to improve performance.
Attention mechanisms have greatly improved the performance of many language models. Yet with great power comes increased complexity. In this work, we present attention flows, a visualization that lets users interpret the language model's decisions and gain insights into the underlying self-attention mechanism. We also support model comparison that helps to fill the gaps between models in different training stages.
Do these three essays construct their argumentation similarly? Where in this table of argumentation data from the previously seen texts can I find certain argumentation patterns? Do these three argument maps depict the same argument? We have developed a visual analysis system for argumentation in essays that can answer these questions at a glance. You want to know how it works? Come to my talk.
We propose a new semi-automatic method that uses topological features to guide users in tracing neurons, and integrate this method within a virtual reality framework. We use the Morse-Mel complex to find a set of candidate neuron arcs. The candidate arcs are integrated into a VR neuron tracing system and exposed through our Morse-Mel complex guided semi-automatic tracing tool. The topological ridge graph underlying our MSC guided tool is robust against gaps in the signal.
VIS is a visual support system for the development of visualization algorithms. It has live compilation, automatic version control, predefined interactions, and tools for visual parameter analysis. By displaying the complete history of the algorithm, users get insights into the correlation between source code changes and visual differences. We have seen many visualizations for tree data structures, but when showing changes in trees over time, some focus on displaying hierarchy, while others highlight their changes. With split streams, we combine two approaches and their individual benefits. We evaluated our method in a user study and consider it a general-purpose method for the visualization of dynamic hierarchies. Our JavaScript library is openly available.
As data is changing, our understanding of data should be updated correspondingly. Based on machine learning approaches, we formulate a drift level index to monitor the evolution of multi-source data, which allows users to capture and reason significant changes from time series data. The proposed visual analytics system is called Concept Explorer. More details can be found in our talk.
We asked participants to recreate bar graphs. When the bar was alone, we saw a different pattern of error than when the bar was presented with context in a stacked bar graph. We found that absolute error increased for higher bars when they were presented alone. We also found that there was a bias in the responses such that they were repulsed from an implicit 50% mark. We found a magic number, 10%, to predict error. Participants are usually within 10% of the height of the bar.
In our paper, we address the problem of navigating complex multiscale and dense environments, such as these molecular models. We present a technique for browsing a model by clicking on textual labels, which we call hyperlabels. This allows the user to intuitively navigate the hierarchical organization of the model. For more details, read our paper or watch the talk.
Progressive visual analytics provides intermediate results in the middle of computation to address a long computational delay. However, such intermediate results are uncertain, so findings from these results can turn out to be incorrect for the entire data. In progressive visual analytics with safeguards, we suggest to risk the uncertainty, but we allow humans to leave safeguards every time they risk the uncertainty.
As commonly known, dimensionality reduction techniques and their interpretations are complex, biased, and uncertain. In drug design, this highly complicates the search for similar and new chemical compounds. To overcome this issue, Canva brings comparison of different molecular descriptors and properties into one tool, featuring planar, 3D, and table views for evaluating the trustworthiness of high-dimensional data projection.
Syringe graphs are variants of stack graphs with curve baseline, and the main factor affecting its readability is the sign allurance through a perceptual inconsistency of the orthogonal and vertical direction. Aiming at reducing its impacts, we revisited the baseline formulation and proposed the concept of composition to help the syringe graph layout optimization. The result shows that our algorithms perform better than the others.
Hands-on cybersecurity training represents a domain where visual analytics can significantly improve the impact of teaching process. We describe this new application domain and introduce a conceptual model that can serve as a framework for the development of analytical visualizations. Unified training lifecycle will be discussed from the perspective of different user roles.
Linking and brushing is very useful for interactive visual data exploration. Data-driven brushing tools are getting popular recently and achieve good results, for example the Mahalanobis brush and the CNN-based brush. However, these brushing tools are optimized by the data from a large number of users, which are not suitable for everyone. In this paper, we introduce an adaptive brush model which takes the user in a loop to improve the brush accuracy.
Asteroids have always been and will always be a threat to life on Earth. Most likely, an asteroid will hit deep water, but what properties will actually lead to a threat like a tsunami? Ensemble simulations are a common tool to understand the effect of different parameters like the size of the asteroid. We propose an interactive visual approach to help analyzing deepwater asteroid impact simulation ensembles.
Program developers spend significant time on optimizing and tuning applications. But working with binary code to understand what compiler optimizations were applied can be challenging. We present our visual analytics system, CCNAV, designed to identify and assess compiler optimizations in binary code. Check out our paper to learn more.
When developing a deep learning model, people typically struggle to optimize hyperparameters that affecting the model performance. To relieve the pain of this manual trial process, AutoML has been developed as a solution. However, to maximize the potential of the AutoML, people should identify a good AutoML setting for their task. Hypertender helps to maximize the potential by visualizing AutoML algorithm behavior and guiding effective hyperparameters.
In this talk, we introduce CallFlow, an interactive visual analysis tool that provides a high-level overview of performance profiles from large-scale scientific applications. CallFlow visualizes the flow of resource of a program execution as a Sankey diagram to detect performance bottlenecks in parallel codes. CallFlow simplifies these calling context trees based on semantic information by constructing supergraphs.
Several recent studies advocated the use of non-parametric density models for the improved characterization of data uncertainty. The non-parametric models, however, present the challenges such as increased memory and computational requirements. In this work, we propose an efficient non-parametric framework for volume rendering in the context of uncertain data and show their effectiveness in classifications via comparisons with the other statistical models.
How many clusters can you see in these images? With different visual encodings in scatter plots, our perception of cluster count changes. We developed models that consider how visual density influences cluster perception. Further, we demonstrate using a threshold plot to optimize the saliency of clusters.
In our current work, we visually compare two cohorts of segmented and classified tissue images, originated from single-cell omics data. To that end, we developed data-driven and interactive workflow implemented in a multi-linked view system. Finally, we show the effectiveness of our workflow through specific case studies.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
Text alignment is a fundamental technique in many text-related domains. In this survey, we cover 3 text alignment scenarios: collation task, text reuse detection, and translation alignment. On the basis of those scenarios, we reviewed the existing text alignment visualization approaches and discussed their advantages and drawbacks. We finally derived design implications and shed light on related future challenges.
We present the first generic design space and library for visual piling. Inspired by physically piling paper documents, visual piling describes an interface for spatial organization of visual artifacts into piles of partially overlapping items. Piling affords interactive grouping, arrangement, previewing, browsing, and aggregation to reduce the complexity and support comparison of large collections of small multiples.
How do you visualize the nanoscale, 1 billionth of a meter, for the public? As part of a Science Center exhibition, we developed an immersive environment that explains nanoconcepts by allowing users to explore nanoproperties. We reflect on how exploration, the confluence of explanatory and exploratory visualization, can be applied to visualization in public spaces.
We propose an interactive ensemble analysis framework that provides flexible interactive exploration of the ensemble data. Time series characteristics of data can be obtained by fast browsing time steps. The region stability heat map view shows the stability of the selected region and provides region adjustment by directly clicking.
Visualizing class separations is used in applications such as classification and clustering. However, many dimension reduction techniques are limited due to the issues of separability and interpretability. We propose a visual analytics framework to support the exploration of nonlinear complex separation structures with the power of locally linear separations.
While meetings are an essential part of everyday business life, most calendar visualizations are not designed for retrospection. We present a tool consisting of 4 coordinated views that integrate into the user's daily workflow and are designed to promote self-awareness about past scheduling decisions. We discuss the insights gained from an internal user study and from a field deployment. We also discuss how we strongly inherit from the principles of personal visual analytics despite targeting a professional environment.
Deep neural networks are vulnerable to maliciously generated adversarial examples. This brings high risk in applying these networks to safety-critical applications. We develop a visual analytics approach to explain the root cause of such wrong predictions. Our contribution contains a constrained data path extraction method, a river-based visualization, and a contribution analysis method.
In this study, we designed a system named Causality Explorer to facilitate the causal analysis. Users can explore the causal graph to perceive the causality and its uncertainty, validate the causality with the raw data, and apply the confirmed causality to what-if analysis.
Entities and their changing relationships can be modeled more precisely as temporal hypergraphs, but hypergraph models are difficult to explore and refine. By leveraging domain-specific geometric deep learning models and a new multi-level hypergraph visualization, our technique allows for the direct integration of domain knowledge into the machine learning process. The multivariate hypergraph model structure can be analyzed on different abstraction levels. Simultaneously, experts can integrate their domain knowledge on the fly, and then explore the refined machine learning model.
Digital humanities present great opportunities for testing new visualization approaches and evaluation techniques. However, and given the diffuse character and novelty of the field, it may also be intimidating for novel and senior researchers willing to get started in the discipline. In this paper, we propose a data-driven analysis of visualization for the digital humanities to identify key themes, authors, and relevant publications. So if you want to know more, please read our paper.
Pixel Clipper allows visitors to quickly and expressively extract visual clippings from visualizations and add comments to them. The clippings are useful for engaging the public with complex datasets because they are entry points into the visualization. This can be applied in a wide range of engagement experiences, such as the use of facilitated and ambient displays at public engagement events.
Position is believed to be the most precise encoding channel, but our perception and memory of it can still be biased. Past work has shown that the vertical position of bars in a bar chart is recalled in a biased manner, illustrating both an underestimation and overestimation bias of position. Here we find that the aspect ratios of the bar marks can cause this position bias, specifically resulting in overestimation for bars with wide ratios and underestimation for bars with tall ratios.
We present Lyra 2, a system for designing interactive visualizations by demonstration. To design interactions in Lyra 2, users directly manipulate the visualization canvas. The system interprets demonstrations using heuristics and suggests possible interaction designs. We find that Lyra 2 enables rapid prototyping of an expressive range of interaction designs. We're excited to share this work with you.
A testing environment for continuous color maps. Many other fields in the computer science do it, we should do it too. With our work, we introduce the approach of using test functions as a standard evaluation method. We present a test suite for continuous color maps implemented in the CCC tool. Adapt the task to your requirements at the interactive testing section and observe them at the testing evaluation section.
Morse complexes have shown a great utility in understanding the topology of complex scientific datasets. The noise in the scalar field, however, can significantly distort the Morse complex topology. Hence, we study the extraction of Morse complexes for ensembles of noisy scalar fields through their uncertainty visualization using our proposed statistical summary maps.
Scatter plots and parallel coordinates are widely used for visualizing multivariate discrete data. However, for multivariate continuous data, the continuous scatter plots and continuous parallel coordinates are more suitable. In this work, we extend them to uncertain data. Additionally, we also extend fibers to uncertain data. If you are interested,
welcome back, everyone. Hope you had a nice coffee break. We start now with the second session of the workshop, and first the presentation of the two papers that were accepted and that will be presented now at the workshop. So first we have a paper presentation entitled Expectation versus Reality, the Failed Evaluation of a Mixed Initiative Visualization System from Sunwoo, Melanie, Bancilhon, and Alvitta Ottley of the Washington University in St. Louis, and Adam Kern with MIT Lincoln Laboratory.
Hello everyone, my name is Sunwoo, and today we will be talking about my failed evaluation of a mixed initiative visualization system. Evaluation and visualization studies show how visual aids can support all who must interact with data in understanding and communicating that data. Historically, this has been accomplished using controlled in-person experiments. With calls for more valid evaluations from a more representative user study population, there has been a relatively recent tendency to collect data via crowdsourced platforms in place of an undergraduate student population. Here and Bostock and others have successfully replicated pioneering studies using platforms such as Amazon Mechanical Turk and have produced more generalizable findings that involve a more extensive and diverse population. Our agenda was motivated by the need to improve data exploration for small but crowded data visualizations. In particular, visualizing every data point can lead to overplotting and information overload. We aim to manage this by presenting a mixed initiative visualization system that uses a hidden Markov model algorithm developed by Ottley et al. To capture and predict user attention. As the user clicks, the system adaptively responds by bringing data points that the user is likely to be interested in to the foreground. We hope to create a system that allows for an informative overview that reduces the need for visual transformations and encourages easier exploration. Our experiment used two datasets, Toronto restaurant data from Yelp and St. Louis crimes from the Metropolitan Police Department of St. Louis. Details of points are provided in two forms. 1. A tooltip that appears on hover, and 2. Information cards that are added to the sidebar on click. Lastly, a legend at the bottom right of the screen also serves as a filter. We conducted two online experiments to determine the effect of a real-time adaptive system on user interactions and system usability. For each study, we recruited 200 participants via Amazon's Mechanical Turk. Our experiment used two previously mentioned datasets and two conditions, responsive and unresponsive, to study the effects of adaptive systems, creating the four groups shown here. Inspired by Loot and Here, the participants were asked to take some time to interact with the visualization and explore the data to gather insights. Once the participants felt that they were familiar with the dataset, they were given the opportunity to write down as many or as few insights as they would like. Before publishing our study on Mechanical Turk, there were some expectations that we put on users. First, the main way that users would interact was through clicking on points. Second, the users would be able to provide useful insights about the data. Lastly, the responsive system would elicit fewer zooms and more insights. Overall, we hope to see the adaptive system have a significant positive impact on users' interactions and subjective feedback. When we take a look at the results from the first experiment, we found that, number 1, people wanted to hover. Due to the lack of interaction through clicking, we narrowed down the dataset to 41 participants whose interactions met the expectations of the experimental design. Even though there was a threshold for the hovers that we considered in an effort to separate incidental versus intentional hovers, we could still see a strong preference for hovering over clicking in all conditions. Since we use clicks as input to our system's algorithm, our responsive conditions were largely ineffective. Secondly, we found that most insights were shallow. We hand-coded written insights and categorized them as deep and shallow based on the amount of information that they contain. A shallow insight is an observation attained only through minimal interactions. For example, there is a large concentration of Chinese restaurants in one area. A deep insight requires building knowledge of the dataset through interactions. For example, There must be a Chinatown or Asian American populated area down Spolinda Avenue between and including Dundas Street West, College Street, and Beverly Street. Participants in our study entered a total of 779 insights, of which 32 were classified as deep. We believe that the lack of differences between the conditions was because the information given on hover was nearly identical to the information given on click. It is possible that this gave no incentive for users to click on data points. This was particularly problematic in the context of our experiment since we relied on user clicks to trigger the experimental condition. Due to the flaws in the interface design, we reran the experiment. We kept much of the experiment design from experiment 1, but we made 2 minor changes. Number 1, we removed the tooltip on hover. This meant that the participants only saw details on click. Number 2, we added additional guidance for formulating insights. Results from the second experiment showed that the user still did not want to click. There was a moderate increase in the number of clicks. However, we observed a pattern similar to experiment 1 and found that 110 out of 200 participants clicked on fewer than 5 data points. An analysis of the remaining 90 participants revealed inconclusive results. As we can see in this table, the majority of interactions were through hovering and zooms rather than clicking. Similar to the click finding, we observed a slight increase in the number of insights and moderate improvement in the quality of insights. Participants in the second study entered a total of 1,045 insights and only 79 were classified as deep. So what did we learn? The finding that people may not interact with visualizations in the way that we expect them to is not new. Reports from the New York Times suggest that users prefer scrolling as a means of interaction, which has led them to reconsider their investment in interactive visualization. Many researchers believe that the purpose of visualization is insight. Although there is prior work that define and characterize insights, insight-based evaluative methods, especially for online studies, are not clear. Many of these existing studies captured insights in laboratory settings. In addition, the open-ended nature of our tasks made it difficult to filter the participants who were clicking through to get paid. This potentially highlights an important limitation of online studies and provides suggestive evidence that open-ended tasks may not be appropriate for this experiment setting. Not all findings were negative. The fact that users found the visualization well-designed yet were overwhelmed by the size and density of the datasets indicates that the chosen datasets worked well to induce a need for an assistive or mixed initiative agent to help users make sense of the data. Hovers could be a proxy to eye gaze and provide us a better understanding of a user's interests in real time. A possible direction would be to incorporate hovers along with clicks to the algorithm. We had difficulty in obtaining insights that were deep and in good quality. It would be interesting to see if a mix of closed and open-ended tasks will help increase the quality of insights for Mechanical Turk users. It is tempting to say that the results we found supports the alternative hypothesis and conclude that the adaptive system did nothing. But it is more accurate to say that we do not have enough evidence to reject the null hypothesis. Why is this a crucial distinction? Because it does not destroy any hope of an effective mixed initiative system. It is important to note that these results should not dissuade researchers from further work on adaptive systems like the one we designed. Although we were unsuccessful in achieving the data that we expected, we found significant and unexpected findings from the users. When developing these systems, it is easy to assume the users will interact the way that we want them to. Since we made an assumption that users would mainly show interest by clicking on the points, our system was unable to aid the users when their interactions did not meet our expectations. We have learned from our failures and hope that the VIS community can also learn from them too. Thank you. Any questions?
Yes, she is.
Yes.
Jennifer, hi.
Hi. Sharing my screen? What would I be sharing?
I think it's fine to just show her, right?
I am. Is my camera not on?
It is on.
Yeah.
Yeah. Yeah, I'm here. we live now? Thanks a lot for the presentation. So we have a couple of questions that started arriving here. The first one would be what role you think the existing interfaces that are in the world, like Google Maps, for instance, and the lack of visualization experience from regular users play into the struggles that you actually noticed in the paper?
Yeah, so we are currently in the world of data, and so when we are looking at like certain data points, especially like on maps, it's hard to like as shown as like in my example, the Toronto map, it's really hard to like zoom in and figure out, like get a whole general layout of the data because it's so densely populated. And so if I were just looking at just a bunch of restaurants in Toronto because I'm not sure where I would want to go, then that would just be a lot of information to the user that would cause a lot of overload and confusion and may sway the way they interact with the data.
Let me just check the question popping in. So I have one on the side. So as an aside, I actually really like the way you presented things in the paper, like what you expected versus what you actually obtained with the data. You mentioned at the end that readers should not, go around and fall for the fallacy of accepting the null hypothesis, which would be in the case that the system that you had did nothing per se. I obviously agree with this. I've mentioned in my talk before that we should try to avoid dichotomization of evidence anyways. So I totally agree with this. But I wonder what you think readers take from, from reading a paper. Like, don't you think they're going to read this and say, oh, well, it's not very likely to yield any publishable results, because we all know it's difficult to publish results that are not positive. So what do you think is the impact of this?
I think the impact of this is that we all make mistakes, and it's okay to make those mistakes. And based on those mistakes, we were able to find some findings that were interesting and that we could adapt to our next experiment. And so the fact that this paper was published is basically giving researchers a way to not lose hope and try to find some findings from your unsuccessful results, basically, because now we can figure out that users kind of like hovering over clicking, and so maybe adding more hovering to the data, to the algorithm, or we can ask more specific tasks for the user, because the open-ended task was a little bit of a struggle for the users. So yeah.
One question from Jordan, actually, that I think is quite linked to this. When we run experiments with users, we usually have a very specific set of users. How do you think your results would generalize? Like, do you think that it's likely that I would get completely different results if I try to replicate exactly what you did with exactly the same system?
It's kind of interesting because we did it through Amazon Mechanical Turk, and so we tried to get as much of a diverse population as possible through Amazon Mechanical Turk. So I'm hoping maybe that you would get some of the same results, but Mechanical Turk is often really noisy too, and there are some participants who try to just click through. Oh, I'm sorry, that was my dog. There are some participants who try to click through just to get paid. So, but once filtering through the noisy data, then hopefully you should be able to replicate.
Right. Yeah, I meant if you didn't use Mechanical Turk, but yeah, I totally get what you mean. Another question that we have quickly. What was your reaction right after things didn't go as expected? Like, did you step away from the project and just be like, oh, this is not going to work? Or did you actually take it as something interesting that you wanted to get more data on?
I was at first frustrated, but then after analyzing the data, I was kind of intrigued as to why people were not interacting with the visualization the way that we wanted to. And so that is why we actually decided to write this paper, because we wanted to figure out like why is our experiment not working the way that we want it to. But yeah.
Cool. Thanks a lot for the paper and the presentation. That was very interesting.
Thank you for having me.
So next up, PhD student cope with paper rejections, a paper from Shivan Agarwal, Shahid Latif, and Fabian Beck of the Hohe Institute of Software Technology at the University of Duisburg-Essen in Germany.
Hello, my name is Fabian Beck. I'm presenting this talk on behalf of my PhD students Shivam Agarwal and Shai Latif. Due to a bit of unfortunate timing and logistics, they were not able to record the talk themselves as originally planned. But I hope they can be both present today and participate in the workshop. This project was much more their initiative and contribution than mine. This workshop is on failures. And you probably all know those that start with, "We regret to inform you." As a young PhD student, this can be a severe thing. Your day or week might be wrecked, and I hope not your PhD thesis. So we wanted to know, how do PhD students in visualization research feel about it? In particular, what are their coping strategies for paper rejections? To learn about it, we performed a study among the PhD students of the community. We asked them to fill a short online questionnaire, including demographics and information about their publication history, of course with a specific focus on rejections. The main part then consisted of 4 open-ended questions that we will go through later in detail. For the analysis of the results, we used a mostly qualitative approach, in particular an open coding process to identify different coping strategies named by the participants. If you want to look at the data yourself, all materials and results are available as supplemental material published on OSF. We recruited the participants through mailing lists of the community and social media. We analyzed the data of 24 participants. They showed certain diversity as desired. The experience level spread from people in their first year up to recent PhD graduates. We reached an international audience, however, with a certain focus on Germany and the US. But most importantly, the participants had various levels of experience with paper submissions, the blue bars, and paper rejections, the red bars. Before describing the results in detail, I like to quote 2 responses that give a good impression of some general attitudes. One participant said quite positively, "My attitude is this will get in somewhere eventually. I have seen my papers improve dramatically after revising and resubmitting." Another participant expressed more negative feelings, but still with a positive touch. "It was really hard to not give up. There were many tears, but in the end you have to stand up again and improve your work." It's hard to say that these examples are representative, but our impression is that they mark a certain very common span of answers. But now let's discuss the most common coping strategies we identified. First of all, improving the work for a resubmission seems to be the most common approach. We identified this strategy 32 times. Please note that multiple counts per participants are possible here because we extracted the strategies from multiple questions. Second most frequently, we found a kind of opposite strategy, downgrading the work by resubmitting to a lower ranked venue mentioned 21 times. Further coping strategies are discussing the reviews among the collaborators to better understand and derive actions, to wait some time, look at the reviews again later and get a more positive and constructive view on one's own paper, and to consider the rejections as something positive, as an opportunity to improve the work or learn something. As mentioned earlier, these main results are based on a set of 4 open-ended questions, which we can also analyze individually. First, we asked about what support collaborators provided to handle the paper rejections. The answers showed that discussing the reviews with their peers and supervisors was an important step, followed by making a plan for a resubmission. Second, going into the specifics of such resubmission plans, we observed again the 2 main strategies, downgrading and improving, here with a slightly more pronounced focus on downgrading. When choosing a venue for resubmission, mostly one with a similar scope was picked. Third, some papers get rejected multiple times. How are such rejections handled? The interesting thing here is maybe what nobody does, abandoning the work and starting a new project. Else, answers were similar to those for question 2. Fourth, immediately when receiving the notification and reading the reviews for the first time, one might have quite negative feelings and maybe also a negative impression of the review. And indeed, we found when asking how the impression of the reviews changed over time that mostly the impression of the reviews got better. Discussing the outcomes of the study on a higher level, we first need to mention some limitations. One thing is that it's unclear how well our set of participants reflects the community. At least we observe a certain sampling bias towards Europe and North America. Also, to provoke more responses when advertising the study, we implied that PhD students might have faced problems and negative feelings when receiving a reject notification. But despite this potential bias towards the negative, we observed a generally quite positive attitude. Regarding the high-level insights, we can summarize that PhD students take the reviews seriously. Following the review's advice is very common. So papers get improved and also published. No hard research work ends up unpublished. Team support seems to be an important for coping with rejected papers. And PhD students are mostly able in taking the reviews positively and learn from them. Still, we also found some indication that some reviews are written in a quite harsh tone. To conclude, the 5 most common strategies for coping with paper rejections are improving the work, downgrading it to a lower ranked venue, discussing the reviews and resubmissions plans among collaborators, letting the negative feelings pass and looking at the reviews again after some time, and staying positive, seeing the paper improve and learn. As our next steps, we plan to extend this work. We actually have more data available as more responses came in while we were about to submit the work. We also like to analyze in more detail if and how gained experience leads to altered coping strategies. Furthermore, a reviewer's or advisor's perspective would be a good complement to our result. Finally, you might ask us, so is the system healthy? And we would reply, yes, mostly. But reviewers, please consider you might talk to a first-year PhD candidate.
Ready? Yeah, ready on my side.
Yes.
Me too.
Thanks a lot for the presentation. Congrats, guys. So a couple of questions coming in. I can start with one of mine in the meantime. So aside from the content of the review, I personally find it still sometimes quite frustrating to see decisions based on an acceptance rate for conferences in particular. Is it something that any one of your respondents actually mentioned?
Not specifically about the review scores, but yeah, I think we had responses where participants mentioned that they face difficulties in understanding the reviews scores themselves because of unclear reviews or they were not in sync with the score.
Let me check if there's more questions for you. Not yet. So I have more questions. I think it is very fascinating work. So I have a lot of questions prepared anyways. In the data that you have, was there any kind of mention of the differences between a conference review and a journal review, for instance, or how students would cope with it? Because for instance, a conference is a rejection per se. A journal might be a revise and resubmit, which is still pretty difficult to get sometimes. Do you have some data on this?
So maybe not a lot of data on this one, but I think some participants of the survey mentioned that the reviews in the journal are more detailed with a bit more, I think, stuff towards what you can actually do to improve the paper. But that was maybe one or two instances, not a lot to, put as an evidence to say that among those 24 participants. But yeah, please go ahead.
Please go. Just to add that they also mentioned that it takes many cycles, which is possible in the journal, but not in the conference.
Yeah, right.
Yeah, so definitely in a conference, so it's like a accept or accept with a minor revision or a reject. But in the journal, you can also get like a, what do you say, major revision, which you can go through like multiple times, and so gives you more time to revise and improve the paper.
Right. There's some question popping in. One from Jane. As researcher yourself, did the responses from your survey participants cause you to reflect on your own experiences in research? Like, did you feel like, okay, I'm not alone out there somehow when reading all of that?
Answering that question might take longer. Actually, that was the inspiration with which we started the project, that we were driven by our own failures in paper rejections. So yes, I think personally I felt a lot comforted in reading the responses of participants. We had this thought in the beginning that we must not be alone in facing these multiple paper rejections. So it was, yes, definitely very comforting.
Yeah, just to add on that, so I think since we are working in the same group, although a rather small group, but we do like a lot of coffee breaks and go to lunch together. So we used to discuss all these kind of whenever getting a rejection notification, used to discuss this stuff among ourselves. So I think there was also some strategy. So we thought we are not alone kind of discussing this. So it helps a lot. Also, the other students mentioned that many times. Kind of discussing the reviews, not in a formal setting like to your supervisor or in a formal meeting, but rather on a coffee break or let's say going out for drinks and talking about the rejection, that kind of lifts off the pressure.
Right, that makes sense. One question from Jordan here. Did you find evidence of like how the faculty, like more senior researchers or advisors, respond to the students' failed paper somehow influence how the student themselves could consider rejection and interpret the feedback that they get in the reviews, perhaps?
Yeah, actually, that's the next step which we plan to do. So in the extended version, we plan to include the perspective of senior researchers and even the reviewers also. But yeah, for this study, as of now, we don't have the data on how senior researchers influence the perspective of students, right? My personal opinion is that this kind of paper should be the first thing which young PhD researchers should be given to read and see that, okay, rejections are common.
Totally agree. One question from Melanie here that kind of echoes a question I had as well. What are your thoughts on the paper peer review process in general? Like, do you have any consideration for improvements on the current system or alternatives to the system itself?
Yeah, I think overall the reviewing process is pretty good as we find out. But I think it also depends on the very junior PhD students, for example, getting the first rejection. So among themselves, I think they are a little bit confused when they get reviews, especially when they are written in a harsh tone or when they contain some conflicting opinions on that. So they sometimes have a hard time fixing those problems. But as you go through, like you're more experienced for or third or fourth year PhD student or have faced more rejections and went through the process, I think they have learned this process of having this high level reflection of the reviews. So they don't take it too personal, or they don't try to answer it like every question. So I think the template we have seen earlier today, that might be a really good point to answer to the reviews. But more senior, I think PhD students or postdocs, they tend to take them less personal and try to have also, I think, attach their own personal opinion to the reviews, what they think that's right.
Cool, thanks a lot for your answers, and thank to both of your the presentation team for these exciting moments in data. I'll hand over the mic now to Jane.
Thanks for having us.
Next up, we have Nadia Bremer on visualizing connections. Nadia is a graduated astronomer turned data scientist turned data visualization designer based near Amsterdam. She focuses on uniquely crafted interactive data visualizations that both engage and enlighten their audience. She walks us through her experiences with network visualization and stumbling blocks along the way.
Hey everyone, thanks for joining me to listen to my talk. So I'm going to talk about visualizing connections. So I'm guessing that you've heard the saying that everything is connected at some point in your life. And although I don't want to debate whether or not everything is connected, I have found that connections can really, they're everywhere. They are really part of us, of the world, from connections between people, between cultures, within nature and language itself. Some really are just literal connections, while others connect us across time, and others really only exist through the meaning we as humans give them. And in these days, when more data is being collected every day than we could ever hope to explore, the variety of connections being gathered is really opening up the possibilities to visualize more of these complex networks. So I've been focused on data visualization for a few years now, and I like to take on the bigger data sets, those that have a lot of diversity, where I can show other stories besides the main insight. And ever since starting freelancing in 2017, really expanding the range of data sets that I get to work with, I started to notice that a lot of my projects can be seen as revealing connections. Some very obvious, some more subtle, some ending up as actual network visualizations, while others use a different visual form to best display the insight. And in this talk, I'd like to take you through along a journey through some of my favorite connected projects to really reveal the ugly truth that goes into creating these big and elaborate and often interactive visuals and stories. So starting out with straightforward connections, I first want to focus and look at those that live in our collective imagination. Literal lines that are being drawn, and only through those lines do the connections really exist. Constellations. So being officially an astronomer, I have a bias for all things space, and I often find that I get inspiration from anything that relates to space. And I do also see that I create a visualization that has some sort of astronomy theme every once in a while. And for my final addition to a year-long collaboration, I couldn't help but turn back to astronomy yet again. So this collaboration called Data Sketches, which I did together with Sunwoo, who is like me also a database freelancer, consisted of 12 projects. And the final project that I tackled had to be about myths and legends, which through a winding road of ideas eventually led me to the concept of myths in the night sky. Sure, I can pinpoint some of my favorite constellations, but those are all from Western culture, and I was wondering, what about other cultures across space and time? What if they see it in the same night sky, and are there certain shapes that almost every culture identifies with? So I drew a simple sketch in my notebook, but in my mind, that sort of sketchy circle in the bottom left would eventually become something that would really also mimic or be inspired by the amazing historical sky maps that you can find all over the web these days, thankfully. And so full of enthusiasm, I crossed my fingers, hoping that diverse cultural constellation data would be available online. Thankfully, I didn't have to search very far because I stumbled upon Stellarium, which is an amazing free planetarium software, and even better, it's open source. So after some digging around, I found that they have constellation data available for 28 different cultures that I could use. So I looked, first some initial data preparation, it wasn't much, but then I looked up some sort of sky maps that I could find online based in the code of D3, which is a JavaScript library that I use for basically all of my visualizations, and it's also really just the data visualization for the web library these days, I think. Because I prefer generally not to start with empty code. And, well, no code. And these snippets, these code examples, they were actually pretty simple, straightforward. There wasn't a whole lot of code going on. So this was one of those very few cases where I thought that I had written all of the correct code on my first save and reload. But of course, real life happened and all of my stars appeared in a line. Looking a little bit closer, I saw that I'd missed a very subtle data transformation step, and fixing that did make my stars appear all over the page, but, having my confidence deflated, I didn't actually know if that was correct or just a happy coincidence. So I added two things that I knew would provide the right context. I added a background grid, which helped, but I also added the lines of the Western constellations that I know and that I immediately saw Orion, which is my favorite constellation, so... Yes, the stars were in the correct place, and this is in essence already a sky map, but a very boring one though. So I tried several things to make this sky map based more on reality, such as giving the stars the right colors, how we see them based on temperature, adding streaks to mimic the Milky Way, but also remembering what I liked from those old sky maps and getting inspiration from that, such as the inclusion of the ecliptic line, clipping it all to a circle, zodiac signs, all these things. So I'll spare you the details because this is basically just setting up the chart area, but this is how my sky map looked after I was done with all of these sort of more chart subtle things. And now the data viz part really came on, and what would make my sky map different from the general sky map was the inclusion of many constellations at once. So the approach that I thought out was pretty straightforward. I would focus on one star, and then I would show all of the constellations that used that one star. Because of course many different cultures would use the stars in different ways. I started out with creating these sort of mini donut charts around all the stars that were being used in all of these constellations. And because again, like even though you have that main star, the other stars are being used as well for different constellations. And after that, I wanted to draw these constellation lines, one for each of the constellations between two stars. And I start sketching out some thoughts and ideas of how to calculate these offsets of the lines in my notebook. But after a little while, I figured that it could instead be done pretty easily with some simple vector math instead. So still some little bugs to iron out in when I finally coded it, but that's how the parallel lines came about quite fast actually. And this is how the constellations look for everything that uses the star Betelgeuse. And when I first saw this, I was so amazed to see how many of these cultures are using this sort of same general shape of a rectangle tightened by a belt. But of course, every culture sees something different in the same shape, from heroes to mythical animals to objects to the kings and so on. I also really like how some just completely defy convention and see their own shapes in it, like this sort of man with a, boomerang staff from the Navajo, or this other sort of old man from the Tupi. And the brightest star in the night sky I found very interesting. Sirius doesn't really have any very common shape at all. It's not even used that often in constellations. I also saw this really cute deer-like shape in the southern hemisphere, which I hope to find once I do get down to the other half of the Earth again, but it seems pretty tricky to find, but I'll try. And what seems to be the most common shape in all of the datasets that I had is the one that most of us know as the Big Dipper. And I turned that all into a full article, which you can see lots of more stars and other things that I found from this data set on how different cultures have seen connections in the night sky. But I believe that probably when most people think of connections, they think of family ties. You know, how you are connected to your parents, your partner, and your children. And for another project in that Data Sketches collaboration, the topic was presidents and royalty. And I've always been intrigued by how intermarriage the royals really are. You know, are they all cousins twice removed, or is it farther than that? And I didn't want to have just the sort of the family tree of one royal house, so I can make something more normal looking like this. No, I wanted as many connections as possible, going back hundreds of years and crossing European royal houses. And thankfully, again, I was lucky to find a data set that contained the family tree of 3,000 people connected to European royal families, and it went back more than a millennia even. It was from 1992, so I did have to spend a few hours, several hours, on Wikipedia, adding one or two more generations in the main line of succession. And I have also learned that, you know, the design of a website says nothing about the quality or interestingness of the data that it shares. So I also looked up some more famous royals because, you know, a good time to learn more about the data that you have. But in general, the problem that I have with these more interconnected webs of networks is that it's very hard to draw out anything less abstract than just circles connected by a line. And that's because the best way to visualize a network is often so very inherent to the connections within the network. So really only what I can do is just place all of the points on the screen using my most basic network settings and then trying to figure it out from there, which is exactly what I did here. So I put everything on the screen, and then this happened. An explosion of points and lines moving out of my screen. So I thought I'll put in a little bit more gravity so things don't fall out that far, but then I was immediately left like with a tipping point with this sort of useless hairball. Coloring everybody by year of birth wasn't really helping either, but thankfully in the browser you could play with the laws of gravity, so I pulled this web apart by year of birth as well, which was better, but it was still a rather uninsightful bundle. And at this point, I'd already invested several hours into playing with the network settings, trying different kinds of ideas, and adjusting my data. And I was really ready to just kind of move on and try a different angle, like how much are the royals spending these days? But I gave it one last shot. And that's when I decided to focus on the current royal leaders. So I placed these in a line, and then I let the vertical gravity depend on which of these royal leaders you were most closely related to. And that's when I finally saw it. Insights. For example, that the Queen of England and Denmark and King of Norway are heavily interconnected, but that the Prince of Monaco line separated from Europe more than 200 years ago. And it was only at this point, once I finally found that I had a handle on the visual form, that I started thinking about the visual design aspect. And really, networks often remind me of constellations, and that's basically the only reason why I turned it all into a starry night, making each person into a little star. Here is the final result where everything's rotated 90 degrees, so it better fits the screen. And yeah, I added two types of interactions because I wanted people to explore the connections within this network. So if you hover over a person, like Pauline of Württemberg, you can see she is connected to 6 current royal leaders within only 6 steps. So it shows you how far 6 degrees of separation sort of reaches into this web for that person. So for her, it's actually quite far. The second form of interaction is that you can click on a person like the Queen of England and click on anybody else, like say Sissy, and then you see the path, the shortest path between them. So these two are apparently not extremely closely related. I'm not quite sure when it goes from close to far, but anyway, the King of Norway and the Queen of England are basically family. So this process did show me that yes, the entirety of the European royal family is connected, but you know, maybe not second cousins everybody. Maybe 200 years ago though, it was more entangled then, but not anymore. So I was connected to the Guardian US by a mutual friend, and through the Gates Foundation they have an entire news section on their website that focuses on homelessness in America. And for their flagship piece at the time, they wanted outside help. They had been looking for, so they've been requesting data from cities and shelters about how homeless people were being bussed around the country. So they get a bus ticket and then they have to go somewhere, but it's only a single ride. And they were looking for someone to bring the insights to life of that data. Because I knew that would be too big for me alone, I asked Sunwoo, my partner from the Data Sketches collaboration, to come help me out here again. So with my data science background, I took the data cleaning and analysis part on me, and of course all of these Excel sheets and PDF files that I got were completely different, but the truly bad part came in the shape of typos and state errors. Because to properly know where the homeless were going to, I needed an existing city for each destination. So using an official dataset of US cities, I created a collection of fuzzy text matching techniques that would try and figure out the actual city in cases where an exact match wasn't found. And I made sure that I manually checked each of these automated corrections, but I also spent hours on Google trying to find the actual city in cases where even the fuzzy matching was unable to figure it out. And that's how I've come to understand that the US should never have created 4 states that start with the letters MI. Well, lots of hours later, I had finally cleaned all of these journeys, which resulted in a dataset of about 35,000 journeys. And then I needed to analyze it. What did all of these trips tell us? So I created lots and lots of simple plots dissecting the data in different ways, looking for trends. What about age and gender? What about big versus small cities? What destination was most popular? But what if you try to account for distance? And just visualizing where people started, where these homeless people started and where they went to was going to be an important part of the final story no matter what. But just visualizing all of it as lines on a map created one big mess. So I knew that needed a different visual style. Well, partly due to lucky timing, everybody involved could be in the same room together for 2 days, during which we figured out the main story that we wanted to tell and also came up with designs for the different visualizations that would support each of the different conclusions. And Shirley and me divided up the visuals between us, and my main one would be that map of the US showing all of these journeys. And already during these meetings, I drew an idea where instead of all of these lines, each journey would become a little streamlet moving from start to finish. And then over time, circles would start to grow behind these cities to show how many of the homeless people had actually gone there. Well, back home and trying to actually make it, I always start out very simple, of course, with the most basic map of the US, and everybody started and ending at the same time. And then I was actually kind of surprised when I first reloaded it and saw like 10 mini US sort of shapes moving into the bigger one. Giving everybody the same speed made it look like shockwaves moving over the US, and then making sure that everybody started at an actual sort of timeline scale made it look a lot more sort of visually correct in a way, thankfully. And then I spent a lot of time trying to do different things with these circles and these streamlets, such as being able to follow a person for a little while, but actually eventually we figured out that we wanted to really focus on these journeys just happening, and it didn't really need anything else than just these journeys. So let me show you and quickly go to the Guardian website. Here's the article, the final article, and here we have that map of the US, and there's actually also something going on called scrolly telling, which is where sort of the visualization stays in place, and depending on how far you've scrolled down, a different kind of interaction or visual state happens, so that the text and the visual are always in sync. So we're getting up to the journeys right about now. So yeah, so here they're going, and really the goal of this particular animation was that I see that it has some trouble with the animation, maybe too many things happening at once on my screen right now, but anyway, should move faster. But the goal here really was to show people that all of these journeys were happening and that they were occurring and moving to places all across the US. And there are lots more of these visualizations in the article, as well as photos and videos and interviews to really try and find a balance between the sort of the personal stories and the high-level insights that this very rich data set gave us. If you are interested in reading it, you can just Google for bust out, and I think that you'll be able to find it. So the next project looks at connections from the angle of the many different cultures that we have on Earth. So since 2003, UNESCO is trying to gather and safeguard an ever-growing list of intangible cultural heritage, which can be anything from skills and practices and knowledge that people see as being part of their cultural heritage. And for the past few years, about 40 new elements get added each year, and the total list is about 550 by now. And you can browse this list in a not so very inviting table on the UNESCO website. And if you click on each of these, you get more information as well as videos and photos, but also something else here in the lower left called concepts. So experts of these cultural elements have extensively tagged each of them. And notice how they're actually primary and secondary concepts, which will become important in a bit. Well, of course, with these concepts being tags in a way, it's probably no surprise that many concepts are used more than once. So all of these cultural elements have been tagged with vocal music, except for one of them. And one man within UNESCO had a vision where people would truly be able to see and explore these connections between these cultural elements, to see that two cultural elements from the other sides of the earth could be very similar if you just looked at like the similarities that they have in these concepts. Thankfully, he had convinced management to give him some budget, and he hired some of the back end and me for the visual side. So he was very upfront in his first email about the scope of this network. At the time, there were about 450 elements, countries, regions, World Heritage sites, some projects, NGOs, and about 1,000 different concepts. So this created a network that would have about 2,000 nodes as sort of the technical term for entities in the network. And between them, they shared a whopping 12,000 connections. And I have to admit, I totally did not know that I would ever be able to untangle that mess. What with the royalty project was only 4,500 connections, and that already proved such a difficulty to tame. But I did not want to say no to UNESCO, so I basically just crossed my fingers hoping that it would all work out in the end. And as with the royalty project, I knew that sketching something beforehand would make no sense at all, so I just plotted all of my points on the screen, and as also totally expected, I ended up with hairballs. Giant, infectious disease looking like things kept appearing on my screen no matter what I tried. But there was one thing, thankfully, that really saved me. Not all of these connections are of equal importance. So UNESCO didn't want to aggregate any of the connections away, but they were fine with me temporarily filtering out anything that wasn't a primary concept. So if we look at those concepts again, here we have the tango, so it has a primary concept of dance, instrumental, and vocal music, but it has a lot more secondary ones. So if I can remove the secondary ones, that already removes a lot of these connections, and then hopefully the result will actually be more ordered and also more true, because primary concepts are primary for a reason. So if I create a network only looking at the primary concepts, hopefully that is actually even better than trying to do something with everything. And here's the first result that I got, where yellow are the cultural elements, and I made all of these concepts really teeny tiny so that, placement wouldn't be an issue. And this looked a lot more ordered. In fact, I thought that I could start to see communities, which would be a great way to untangle the web one step further. So in network analysis, you talk about communities when groups of circles of nodes are more heavily interconnected within their community than they are with the rest of the network. Thankfully, smart people have created algorithms that can find these communities, and then I can use the results to, for example, color each community differently, which is what I did here. There are slightly different purples, but they are definitely different communities. So yeah, that was making sense. And now I thought, well, now I can increase the size of these concept nodes as well and make the ones that are used very often, so the ones that have a lot of these connections, I can make them very big so that they are very visually dominant, because apparently they're important. But in these networks right now, it's sort of, the algorithm starts from a random position. And I thought that I could actually, if because I know where all of these circles belong to, all of these concepts have a certain community, why not let them start out from a community and then place in a circle? And now I'm letting the algorithm, the network algorithm, do its thing and move things around based on their actual connections. And I was very happy to see that even though they could move anywhere, most of them stay very close to that initial point and really only moving apart to make room for everything. Only a few of them are moved in towards different directions, which have more ambiguous connections to other communities. So that showed me that looking at this particular network from the angle of communities was very fitting for this network of cultural elements. And then I introduced all of these other elements back in, placing them on an average location, then running a second network algorithm that kind of shuffled them around again. But in the meantime, I was also getting fed up with the current color palette. So after some iterations, I came up with this one. Still very colorful because that's what I like, but also using different kinds of sort of shapes for different kinds of nodes, regions versus World Heritage Sites versus cultural elements. And I really liked how if you kind of zoomed into this visual, it kind of reminded me of looking at an image of outer space. And my contact at UNESCO, without me saying anything, actually started calling this visualization the constellation, which of course, if there's any kind of astronomy link, I do not object against. But with the circles figured out, it was time to look at the lines. Gray and straight lines seemed boring, so I gave them a curve and made them colored. But yeah, 12,000 lines at full opacity is one big mess, so I had to figure something out for them. Took some iterations and some coding, but eventually I came up with this idea where if you hover over a circle, an entity, it shows you all of its connections, making the primary ones thick and the secondary ones thin. And then if you don't hover over anything, it really only shows you the primary connections. And that's really just the tip of the iceberg of everything that had to happen here, because the client also wanted it to be able that if you hovered over a region, you would go down to all of the countries and then down to all of the cultural elements that were connected to those countries. You'd have to be able to send a query of multiple sort of these entities to the network, which would then all fix themselves in the map. Even if you just clicked on something to fix it, you would still have to be able to hover over any other circle and get information about it. If you zoomed in far enough, the circles would have to start showing photos of each of these cultural elements. There had to be a modal where you could get more information about the entity that you clicked on. And again, more and more and more, and it became quite a complex project, especially just for me. But here is the final result, where we can see how you can kind of explore through this. So let's say, let's zoom in and you can also do a search, but I'll just randomly select one, which I will not try and pronounce, but let's see what they're connected to. So for example, bladed weapons, Hinduism, rivers, makeup. Let's try and find a far one. Caste, mythology. I like mythology. And now we can see what everything is connected to mythology. Like for example, this particular cultural element. Which is again connected to other things, primarily know-how, woodworking, but also more farther away things such as instrumental music. And again, that's how you sort of explore this entire network and go from one direction to another direction, and see how all of these cultural elements, how many of them are very similar and connected in some way. Thankfully, though, UNESCO quite liked your result, and they postponed the original online launch to the actual yearly convention where new items are being added to the list, which was really damn cool. And also they gave me even more funding to make more visualizations, so you can see those as well. Some of them are quite different from this visualization, looking at different ways of looking at the same data in a way. So yeah, that was a really fun project to work on. It took some time. And perhaps not very obvious, but connections can also be drawn within our language, depending on how you look at sentences and similarities between sentences. So for a while now, Google has been asking data visualizers to create data viz-driven stories with Google data. And I've had the fortune to create one of these already, and I was really happy when they reached out to ask me to do another one. So I came up with a few ideas, but one really stuck out at me and my contact at Google, doing something about pets. So having this cute little fluff ball in my house for 15 years and counting now, I do find myself on Google every now and then to try and figure out why she's showing some weird behavior. Why the need to climb into anything box-like? And I was just kind of wondering, what do people in general search on Google to try and better understand their pets? So the concept was that I would get a dataset that contained the most popular questions that follow the words, why does a cat? Or why do cats? Why does my cat? And a few more of these variations. And then the same for dogs. And then investigate this to look at trends and similarities and differences between them and within them. And I drew a very rough sketch on the idea and how I wanted to visualize that data, which you can find here. This is really how I sketch and how I share it with the clients with explanations. But here we have a sort of sentence tree where I deconstruct and then recombine all of the sentences to kind of form this tree-like structure. Let me explain that in a little bit more detail. So eventually I got 2,000 of the most popular questions asked about cats. And from that I can say, well, give me everything that has the word like as the first word. So why do cats like in general? That gives me a smaller list, but even within that, there are 3 questions that have the word boxes as the second word. So I can basically combine that one step further. And if I keep on doing that, and with all of the other sentences, I turn that into a tree. And I can actually create a sentence by following the line from left to right, such as, why do cats like laying on your chest? Yeah, I guess you're like an electric blanket. I guess that's always what I thought it was, but I never Googled that. But apparently people Google that. But this is taking up a lot of space, so I wanted to sort of shorten all of these lines and make it appear in a circle around that first initial sort of word, and also scale all of these circles to the popularity. So why do cats like boxes is very popular, but why do cats like earwax is thankfully less popular. But this is just one aspect of the data, and I wanted to visualize all 2,000 questions at once. So I started up with a very simple network again, and then just slowly thought like, I'll make these connections more apparent, such as, using the distance away to show how many words they'd stepped into the sentence. But I also really needed to increase the scale of these circles because I wanted to place as many words as possible inside the circles of the most important, like the bigger ones. However, that used up so much space that it was really difficult to follow the lines. They were just gray blurs going outward. It wasn't clear who the parent was and who the child was. And then I started trying to do all kinds of different things and try and make that more clear, such as being able to grouping all of the children of one parent, but that really still didn't make it clear who the parent was. And sometimes, like, the strangest things would just happen. Like here, I still do not know why these circles start rotating faster and faster. I don't. I just had to undo my code until it stopped doing this, and every once in a while, it would just come back. Yeah. And at some point I had an idea where I would group all of the children's circles of the same parent in a bigger circle, so there would be only one line between parent and circle and the children. And I first draw it out in my sketchbook if I have like bigger ideas to see if it kind of makes sense, which I did here. And here I had it working for the first time, so child circle holding all the children with only one line. But yeah, when I looked at this, I still felt like it's not really helping me. It's still an overwhelming amount of information. It doesn't really incite me to want to investigate. Stuff did remain to go wrong quite completely. But no matter what I tried with these sort of packed circles, I just couldn't make it insightful. So I tried other things, other approaches, completely other ideas. And I went on for I don't know how many days trying to come up with ideas. Eventually, even making it so that I would be able to drag all of these circles myself so I could place them exactly where I thought I wanted them, when it took me about 2 hours to do it for this right side. And then I took a step back and looked at it and felt like, no, that's still not doing it for me. So about 40 hours after having started with my very first simple network, did I throw in the towel and give up, finally. But of course this was a client, so I still needed to visualize this somehow. And that's when I turned back to one of my many attempts at trying different stuff in those 40 hours, where I had basically cut the connection to the central cat circle, and then each of these branches was becoming its own mini tree, such as like, which we saw before, but there's also lick, meow, need, and have. Of course that took some time to get working as well, but I still remember thinking that I quite liked the look of these sort of mini trees, so I really wanted to continue with that. I came up with the idea where I would contain each of the mini trees into its own circle so that it would be clearly distinct from each other. And the process that now happens is that I just plop a bunch of circles in an area that's the width that the page has. I then use an algorithm to reduce overlap as much as possible so that they are nicely spread out in this area. And once that's done, I run a network algorithm in each of these circles for each of the trees. So here you see a few of the bigger ones happening, but of course for my version I really didn't need it to be animated, so it could all happen under the hood using web workers, thankfully. So I just show the final result. And when I saw this, I mean, it was probably also because I was 40 plus hours, so my my bias was somewhere else than when I was started. But when I saw this, I was like, finally, I'm happy to gotten to a point where it has a good balance between giving people the access to all of the data, so still all of these questions, while not feeling too overwhelming that you wouldn't actually want to try and investigate. And I tried to make that second part even more inviting, wanting to investigate by looking at the design. So I made that very colorful and whimsical and sketchy so that you would really want to sort of hover over this and see all of these sort of things happening. Like, you know, why do cats like to pee in the litter box but poops on the floor? That's nasty. I don't know if the other way around is actually, probably the other way around is worse. But that's sort of how I try to make it look like something that people actually would want to play with. Of course, didn't stop there. I had to do similar things for different visualizations on this page. I went through I don't know how many color palettes and fonts. I had to write the text of the page and come up with a layout for the entire page. I had to have different kinds of interactions on desktop versus mobile, which really exploded the underlying complexity, and I don't like doing that. There had to be a search box for that bigger version of the visual that I showed you just now. But never mind all that. Let's just take a quick look at the final result where we can quickly choose between cats and dogs. So why do cats? So I didn't make these animations. They were made by Juliana Chen, which great animations. And yeah, we first start kind of simple, look at like, whoa, why are cats so afraid of cucumbers? Because of that meme that happens, and that's a very popular question. But after a few of these sort of simpler things, I'm like, okay, so I've shown you what the data is. Here's all the data. Have fun. But we can also look at the same data in different ways and look at the most asked questions, for example, or just generally comparing cats versus dogs. And then there's also an entire page for dogs. But yeah, it was, again, a really fun and probably the most time-consuming project I have ever worked on, but still really happy with it. Alright, so for the final example, we're stepping away from connections that relate to humans and looking at systems instead. So I was approached by a startup, Alice, and they're using machine learning to try and find good investment opportunities. And to do this, they've built their own operating system on which the business runs, called Alice OS. And they wanted me to visualize that system. So a little bit about their data. So each data point is a service, and which can be something as simple as a task to copy a file to something more complex like running a machine learning model. And each of these services is part of a domain, from all file handling services to all machine learning services. And what made it connections is that each of these services can create another service, which can create another service, and so on. And Alice wanted me to visualize that could be used, something that could be used for both management purposes, so showing an overall view of the system, revealing task dependencies, where filled services were, and more, and some metadata. But they also wanted something that could be used for marketing ends, so it had to look visually very appealing and be very much in line with their brand, which basically was just black, white, and red, and these colors, these long exposure photos of car tail lights. So that would be an interesting challenge. So the reason why they came to me is because they felt that the royalty project would work great with their data as well. So in the royalty project, we have time on the vertical axis, and then the horizontal axis is used to sort of untangle this web into the different current royal leaders. And they thought, well, we can use the same setup where time would now be the creation time of these services, and then the domains would sort of be on the horizontal, untangling this web, because services from one domain could create a service in another domain. And the way they explained it seemed to make sense. So I thought, well, yeah, sure, we can try that. And then I programmed it and refreshed my page, and then I saw this. And I thought, well, no, that's not working at all. Domain crossings are happening, but very infrequently. But even more of an issue was the fact that these services were created within minutes, if not seconds, from each other, and after which nothing would happen for quite a while, which would then create these sort of blobs that would just all want to be able to sit at exactly the same location. So yeah, I reached out to the client again. I even tried some other things, trying to make a spiral so the time axis would be really, really long, but just, doomed to fail. So I reached out again, and I told them, like, I really need to go back a step and go into a proper design phase to figure out what actually works for your data. So for the next few days, I would draw something very simple in my notebook and then spend a few hours making it real with programming. And starting out with just a simple circle where everything was ordered according to the creation time and grouped by domain. What about spokes, where each spoke was a different domain, but then you can get these weird things where, well, not weird, you could get these things where one spoke was really long, and how would that really work visually? What about a network for each of the different domains, but that gave me 7 little hairballs, which I did not want to work with. These radial tree, which I thought was very interesting. It really showed the hierarchical dependencies of these tasks very well, but it couldn't actually work for the final result because you couldn't, like, domain crossings could happen, which wasn't visible in here. So this service could create a service here that actually falls into a different domain, like maybe this domain. So that was, again, not the final. I thought maybe the spokes again, but now curved, so I would fix this, the issue of spacing, but now these lines were really going over other data points, which especially here. So that, again, a no. I tried this completely different thing with circle packing, but yeah. Nothing was clearly working. So I took a step back and I thought, like, okay, so what did I like from everything that I tried? And that was basically the initial circle where everything was sorted according to time and grouped per domain. And that radial tree where everything was, like, the hierarchical dependencies were clearly visible in these steps outward. So I thought, well, maybe I can combine those two things. So I basically made a depth circle. I don't know how to call it, but where it would still be following that circle idea with grouped by time and domain, but then children would be moved one step farther outward than their parents. So these two are basically very similar. All of these surfaces are along the same angle around that main circle, but in the right-hand side, they are moved one step farther outward if they have, like, if they are a child of the parent. And I sent this idea back to the client, and thankfully they liked it, and so I continued with making it a little bit more on brand, such as making the currently running services and the failed services, giving them a glow so they would stand out a little bit more. But I also wanted to do something with these lines, so I thought, well, what if I draw a line and they're all slightly jiggled but on top of each other, so we can get this idea of these car tail lights. Of course, it took a little bit of time to figure out how to make the formulas work for even short and long lines. But here that was working. But here you can see, for example, how domain crossing would work, where this service over here created this service, but also apparently these over there. And then, of course, I had to make it animated, interactive, and being able to handle updates to the data. But here's the final result, where quickly showing the animations. We can see the domain, we can see like one service, and then we can see that 2 steps down, this service failed, which cascaded back down, making this service fail. We can focus more on one specific domain over here. And in a similar sense, we can go, like, an update to the data would kind of reveal, show the overlap between the new dataset and the old dataset, like this. So yeah, I'm very happy that I managed to find a way to reveal the connections in this complex system of services, especially looking at how dreadful that initial result looked. Yeah, and like I said before, it's each network really needs its own unique way of revealing the information and the insights most effectively, because it depends so highly on the connections present within the network. And it doesn't just stop there. I mean, we can find connections in the different ways that an organization is set up. We can find different connections between people besides family, such as friends and lovers. We can find connections across time, such as all of the fights that the characters of Dragon Ball Z have appeared in. And yeah, and I hope that these examples have shown you how connections can be amazingly different and complex. And I found that trying to work with them, you really need to use a very creative and iterative and custom approach. Like, some of them are, well, very few of them are so simple that you can actually make a design beforehand, but with most of them I find that they are so complex and elusive and unknown that there's nothing else that I can do but just plop all of the data on my screen and then just continue to design with code, where I can apply my design choices to all of the data simultaneously to see if the results are, effective and visually appealing. Well, if you'd like to explore any of these projects and these and more that I didn't have time to discuss, you can find them all on my portfolio. If you like DataVis, come join us on Twitter. That's really where the DataVis community lives. And finally, thank you for watching this.
Can you see me? Can you hear me? Okay, everybody. So with this, we'll have our closing. Give me just a moment. I have a little technical issue here. I need screen sharing. Hi, everybody. Sorry about that little technical issue. Just a little issue with their sharing. So first of all, on behalf of all the organizers, I'd like to thank everyone who attended this really good workshop. It was a really good experience for me, and I hope all of you found it valuable as well. So we would like to, first of all, thank all of our contributors, because without them, this workshop would have been much shorter and much less interesting. So thank you all for your time and efforts. So with this closing, I wanted to leave you with some take-home thoughts that maybe you can take with you into your future reviews and the future feedback that you both give and receive. So first of all, I would say that failure is a natural part of science and design. And if you're not failing, you're probably doing something wrong. So do keep in mind that when you fail, it's actually a bit of a good thing. Also, you need to keep in mind that everyone fails. All of our speakers today spoke about their own failures, and I'm sure if you work your way up the chain to even the most successful in our field, you'll find that they hit many failures, many bumps in the road. So with that, make sure that when you do fail, you take advantage of those failures and you use those opportunities to learn and improve what you're working on or what you're doing. And finally, when you do have the opportunity to give feedback to somebody else, you need to make sure that you're kind, but also constructive. And so do remember that there is a human being on the other end of that feedback that you happen to be giving. So we, the organizers, would like to continue the conversation beyond this workshop, and we really need community feedback to know how best to proceed. Some of the topics that struck me throughout this workshop include, for example, how do we continue to support each other in positive ways? It seems like informal networks are a pretty important part of the failure process. We get feedback, we're upset about it, we go talk to our friends, and that helps us to move forward. But perhaps we need some more formal support. A next point is that perhaps we can improve the systems that we're using, such as peer review, so that they are more productive for us and they're less painful. With this in mind, I would encourage you to attend the VIS session, which is going to occur on Thursday. And finally, as Jane mentioned in the opening, Other fields have introduced publication venues specifically dedicated to failures, and we should really evaluate if this is something that this community needs. For example, a FailFest could become the default place to publish your failed experiment or your failed design or whatever failures you happen to have come across. So with that, again, let's keep the conversation going. We have a Google form that we'd love it if you could fill out for us to give us a little bit of feedback about your own personal failure experiences. We'll also post that link into Discord so you don't have to rush to type in all of the random letters that you see there. Please do reach out to us on Discord. We'll continue to monitor it for at least the remainder of the conference. We'll continue to monitor our Twitter account, and you can also reach us on our website. So with that, I'd like to thank you for attending, and please enjoy the rest of VIS 2020.
The success of convolutional neural network has been attracting many students and practitioners to learn the exciting technology. However, for beginners, the CNN model is not easy to understand. We introduced the Explainer, an interactive visualization tool to help beginners more easily learn about convolutional neural network. Using the Explainer, users can progressively explore the CNN model with real-life images in their browser, getting a comprehensive understanding of both high-level model structure and low-level underlying mathematical operations.
We present TransVis, a design study that is proposed to analyze and integrate close and distant reading of multiple translations. TransVis presents the overview of the collection to capture global patterns that is facilitated by the ADM-VIV matrix. TransVis integrates a detailed view to explore interesting path of alignments. We also propose the TLC view to examine and explore the terms of the user-selected path to justify and reason the AD analysis.
We present StratGraphics, an approach for designing data-agnostic and fully reusable visualization templates. StratGraphics follows the inverse workflow that common data-driven systems. Rather than starting from data, designers construct visualization structures without relying on a data schema. Data tables are shaped later from the structure of graphics. We demonstrate the power of the approach through a gallery of visualization examples.
The classifier trained on the historical data may fail to classify the incoming data when the data distribution is changing. This phenomenon is called concept drift. To handle the concept drift, we developed the Drift VIS, a visual analytic system to help the expert understand when, where, and why the drift happens, and update the model to improve performance.
Attention mechanisms have greatly improved the performance of many language models. Yet with great power comes increased complexity. In this work, we present attention flows, a visualization that let users interpret the language model's decisions and gain insights into the underlying self-attention mechanism. We also support model comparison that helps to fill the gaps between models in different training stages.
Do these three essays construct their argumentation similarly? Where in this table of argumentation data from the previously seen texts can I find certain argumentation patterns? Do these three argument maps depict the same argument? We have developed a visual analysis system for argumentation in essays that can answer these questions at a glance. You want to know how it works? Come to my talk.
We propose a new semi-automatic method that uses topological features to guide users in tracing neurons, and integrate this method within a virtual reality framework. We use the Morse-Mel complex to find a set of candidate neuron arcs. The candidate arcs are integrated into a VR neuron tracing system and exposed through our Morse-Mel complex guided semi-automatic tracing tool. The topological ridge graph underlying our MSC guided tool is robust against gaps in the signal,
VIS is a visual support system for the development of visualization algorithms. It has live compilation, automatic version control, predefined interactions, and tools for visual parameter analysis. By displaying the complete history of the algorithm, users get insights into the correlation between source code changes and visual differences. We have seen many visualizations for tree data structures, but when showing changes in trees over time, some focus on displaying hierarchy, while others highlight their changes. With split streams, we combine two approaches and their individual benefits. We evaluated our method in a user study and consider it a general-purpose method for the visualization of dynamic hierarchies. Our JavaScript library is openly available.
As data is changing, our understanding of data should be updated correspondingly. Based on machine learning approaches, we formulate a drift level index to monitor the evolution of multi-source data, which allows users to capture and reason significant changes from time series data. The proposed visual analytics system is called Concept Explorer. More details can be found in our talk.
We asked participants to recreate bar graphs. When the bar was alone, we saw a different pattern of error than when the bar was presented with context in a stacked bar graph. We find that absolute error increased for higher bars when they were presented alone. We also found that there was a bias in the responses such that they were repulsed from an implicit 50% mark. We found a magic number, 10%, to predict error. Participants are usually within 10% of the height of the bar.
In our paper, we address the problem of navigating complex multiscale and dense environments, such as these molecular models. We present a technique for browsing a model by clicking on textual labels, which we call hyperlabels. This allows the user to intuitively navigate the hierarchical organization of the model. For more details, read our paper or watch the talk.
Progressive visual analytics provides intermediate results in the middle of computation to address a long computational delay. However, such intermediate results are uncertain, so findings from these results can turn out to be incorrect for the entire data. In progressive visual analytics with safeguards, we suggest to risk the uncertainty, but we allow humans to leave safeguards every time they risk the uncertainty.
As commonly known, dimensionality reduction techniques and their interpretations are complex, biased, and uncertain. In drug design, this highly complicates the search for similar and new chemical compounds. To overcome this issue, Canva brings comparison of different molecular descriptors and properties into one tool, featuring planar, 3D, and table views for evaluating the trustworthiness of high-dimensional data projection.
Syringe graphs are variants of stack graphs with curve baseline, and the main factor affecting its readability is the sign allurance through a perceptual inconsistency of the orthogonal and vertical direction. Aiming at reducing its impacts, we revisited the baseline formulation and proposed the concept of composition to help the syringe graph layout optimization. The result shows that our algorithms perform better than the others.
Hands-on cybersecurity training represents a domain where visual analytics can significantly improve the impact of teaching process. We describe this new application domain and introduce a conceptual model that can serve as a framework for the development of analytical visualizations. Unified training lifecycle will be discussed from the perspective of different user roles.
Linking and brushing is very useful for interactive visual data exploration. Data-driven brushing tools are getting popular recently and achieve good results, for example the Mahalanobis brush and the CNN-based brush. However, these brushing tools are optimized by the data from a large number of users, which are not suitable for everyone. In this paper, we introduce an adaptive brush model which takes the user in the loop to improve the brushing accuracy.
Asteroids have always been and will always be a threat to life on Earth. Most likely, an asteroid will hit deep water, but what properties will actually lead to a threat like a tsunami? Ensemble simulations are a common tool to understand the effect of different parameters like the size of the asteroid. We propose an interactive visual approach to help analyzing deepwater asteroid impact simulation ensembles.
Program developers spend significant time on optimizing and tuning applications. But working with binary code to understand what compiler optimizations were applied can be challenging. We present our visual analytics system, CCNAV, designed to identify and assess compiler optimizations in binary code. Check out our paper to learn more.
When developing a deep learning model, people typically struggle to optimize hyperparameters that are affecting the model performance. To relieve the pain of this manual trial process, AutoML has been developed as a solution. However, to maximize the potential of the AutoML, people should identify a good AutoML setting for their task. Hypertender helps to maximize the potential by visualizing AutoML algorithm behavior and guiding effective hyperparameters.
In this talk, we introduce CallFlow, an interactive visual analysis tool that provides a high-level overview of performance profiles from large-scale scientific applications. CallFlow visualizes the flow of resource of a program execution as a Sankey diagram to detect performance bottlenecks in parallel codes. CallFlow simplifies these calling context trees based on semantic information by constructing supergraphs.
Several recent studies advocated the use of non-parametric density models for the improved characterization of data uncertainty. The non-parametric models, however, present the challenges such as increased memory and computational requirements. In this work, we propose an efficient non-parametric framework for volume rendering in the context of uncertain data and show their effectiveness in classifications via comparisons with the other statistical models.
How many clusters can you see in these images? With different visual encodings in scatter plots, our perception of cluster count changes. We developed models that consider how visual density influences cluster perception. Further, we demonstrate using a threshold plot to optimize the saliency of clusters.
In our current work, we visually compare two cohorts of segmented and classified tissue images, originated from single-cell omics data. To that end, we developed a data-driven and interactive workflow implemented in a multi-linked view system. Finally, we show the effectiveness of our workflow through specific case studies.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
Text alignment is a fundamental technique in many text-related domains. In this survey, we cover 3 text alignment scenarios: collation task, text reuse detection, and translation alignment. On the basis of those scenarios, we reviewed the existing text alignment visualization approaches and discussed their advantages and drawbacks. We finally derived design implications and shed light on related future challenges.
We present the first generic design space and library for visual piling. Inspired by physically piling paper documents, visual piling describes an interface for spatial organization of visual artifacts into piles of partially overlapping items. Piling affords interactive grouping, arrangement, previewing, browsing, and aggregation to reduce the complexity and support comparison of large collections of small multiples.
How do you visualize the nanoscale, 1/1000th of a meter, for the public? As part of a Science Center exhibition, we developed an immersive environment that explains nanoconcepts by allowing users to explore nanoproperties. We reflect on how exploration, the confluence of explanatory and exploratory visualization, can be applied to visualization in public spaces.
We propose an interactive ensemble analysis framework that provides flexible interactive exploration of the ensemble data. Time series characteristics of data can be obtained by fast browsing time steps. The region stability heat map view shows the stability of the selected region and provides region adjustment by directly clicking.
Visualizing class separations is used in applications such as classification and clustering. However, many dimension reduction techniques are limited due to the issues of separability and interpretability. We propose a visual analytics framework to support the exploration of nonlinear complex separation structures with the power of locally linear separations.
While meetings are an essential part of everyday business life, most calendar visualizations are not designed for retrospection. We present a tool consisting of 4 coordinated views that integrate into the user's daily workflow and are designed to promote self-awareness about past scheduling decisions. We discuss the insights gained from an internal user study and from a field deployment. We also discuss how we strongly inherit from the principles of personal visual analytics despite targeting a professional environment.
Deep neural networks are vulnerable to maliciously generated adversarial examples. This brings high risk in applying these networks to safety-critical applications. We developed a visual analytics approach to explain the root cause of such wrong predictions. Our contribution contains a constrained datapath extraction method, a river-based visualization, and a contribution analysis method.
In this study, we designed a system named Causality Explorer to facilitate the causal analysis. Users can explore the causal graph to perceive the causality and its uncertainty, validate the causality with the raw data, and apply the confirmed causality to what-if analysis.
Entities and their changing relationships can be modeled more precisely as temporal hypergraphs, but hypergraph models are difficult to explore and refine. By leveraging domain-specific geometric deep learning models and a new multi-level hypergraph visualization, our technique allows for the direct integration of domain knowledge into the machine learning process. The multivariate hypergraph model structure can be analyzed on different abstraction levels. Simultaneously, experts can integrate their domain knowledge on the fly, and then explore the refined machine learning model.
Digital humanities present great opportunities for testing new visualization approaches and evaluation techniques. However, and given the diffuse character and novelty of the field, it may also be intimidating for novel and senior researchers willing to get started in the discipline. In this paper, we propose a data-driven analysis of visualization for the digital humanities to identify key themes, authors, and relevant publications. So if you want to know more, please read our paper.
Pixel Clipper allows visitors to quickly and expressively extract visual clippings from visualizations and add comments to them. The clippings are useful for engaging the public with complex datasets because they are entry points into the visualization. This can be applied in a wide range of engagement experiences, such as the use of facilitated and ambient displays at public engagement events.
Position is believed to be the most precise encoding channel, but our perception and memory of it can still be biased. Past work has shown that the vertical position of bars in a bar chart is recalled in a biased manner, illustrating both an underestimation and overestimation bias of position. Here we find that the aspect ratios of the bar marks can cause this position bias, specifically resulting in overestimation for bars with wide ratios and underestimation for bars with tall ratios.
We present Lyra 2, a system for designing interactive visualizations by demonstration. To design interactions in Lyra 2, users directly manipulate the visualization canvas. The system interprets demonstrations using heuristics and suggests possible interaction designs. We find that Lyra 2 enables rapid prototyping of an expressive range of interaction designs. We're excited to share this work with you.